Hello everyone and welcome to the stream where we answer the question, how long does it take to run 3 minutes worth of ads? If you think the answer is 3 minutes, not on Twitch. Takes about 6. Alright, hello everyone. I'm hoping at least today I can actually stream, like everything works correctly. Yesterday, well, I didn't have a YouTube chat. Mostly everything works fine. Alright. No dog, so let me put on a little placeholder of him so he's not missed. Alright, it's a little bit too bright. Maybe I need to fix that a little bit. Oh, that gets too dark. I just lower the contrast. Alright, there he is. Just like if he was here. Alright, so yesterday, less than like 12 hours ago. No, okay, more than 12 hours ago actually. I was working on my operating system's file system because I needed to add some changes that, well, mostly I needed to add the ability to write files to FAT32 to that file system. I did it a few streams ago with the 9p driver, which is just a virtual file system that shares files between Linux and my system. But now I need to do it with FAT32, which is an actual file system written by some very, very clever people. I'm gonna do this every time I work with the system. At least my little, I don't know, little bit of happiness that I get from shitting on Microsoft. By complaining about how stupidly designed their file system is. So if you've already heard this story, I'm sorry, but indulge me. Oh. He's here. See? You couldn't even tell when I swapped him out and a fake one out. You can't even tell. It's seamless. Seamless. FAT32. You could make a your mom joke. If you're funnier than I am, which is not difficult, you could make a your mom joke with FAT32. But anyway, such a well-designed file system that actually every file is identified by one of these file system entries. They have 11 characters for the file name, a bunch of attributes, some reserved values, but apparently these reserved values have been used in some versions to indicate case sensitivity. Then we have creation date 10 millisecond increment, whatever the fuck that means. Creation timestamp, which you need to multiply the seconds by 2. Creation date, the last time it was accessed, then the first part of the address where you will find the data, then when it was last modified in time and date, and then the last part of the address where you will find the data, followed by the file size. It's all very cleverly made. You can tell it's not hacked together at all. Another thing, we have a last accessed date, but not a timestamp. We have a timestamp and date for this, but not for this. We only have one. But what happens if you have more than 11 characters in your file name? Well, then you use the long file name entry, which comes in reverse order, last to first, because there can be multiple entries, each of which holds 13 characters. So if you have more than 11 characters and you have 13 characters in your file name, you use one of these. If you have 26, you use 2 of these. If you have 30, you use 2 of these. But you can tell that the actual name is split into 3 different properties that are not continuous to each other. You read this one, then this one, then this one. Then you move on to the previous one, and you read this one, and this one. Then you move on to the previous one, you read this one, and this one, and just like that, so easy, you have your file name. Child's Play. Very well designed system. Clever. Clever, clever, clever. Coffee has not been the best recently. I'm a little bit disappointed in myself. Anyway, luckily all that was already done. I just, again, always love highlighting it every chance I get because what the actual fuck? But what I'm actually working on is writing files. So yesterday I added the ability to write the file, and essentially to do that, we have to identify the file in a unique way. So even if the file gets renamed or even if the file gets moved, it's always the same file. And on disk, it is always the same file. This entry, the file system entry, with these two addresses that are not continuous to each other, adding up to 32 bits total, gives you an address where you can find the actual file. That address won't change. Even if you move the file, what you do is you move the entry. You don't move the actual data for the file, so you're good. Using this address as a serial number to uniquely identify the file. Again, you can change. Essentially, you can change the street name, but you can't change where the actual building is. But that allows me to. Oh my god. That allows my voice to crack. That allows me to write the file. So I just modify the data of the file with new data for the file. Cool. And there's some extra functionality I need to add in case the file grows too much or shrinks too much, but I haven't gotten that yet. But there is another problem, is that the file size is changing. Technically, so is the last modification date and even the last access date, but that doesn't really matter to me. I should probably fill them in, but I don't care. Hello, Blurry Square. So there's that, but most importantly, the file size needs to change. Otherwise, this happens. Nope. Unused variable. Whoops, I actually committed that and didn't realize. My bad. I didn't even get a notification that it didn't build. Alright, so I have hello world in my file, I add EE at the beginning, I save the file, everything works fine, but when I open the file again, the size hasn't changed. It still says the exact same thing that it said before, but it's now cut off by 2 characters because these 2 characters were added in. Meaning, we changed the contents of the file, but we didn't update the file size to be the correct one. And I started implementing that, but then I realized it's not so easy. So we'll have to do that, which is very, very fun. All right. Issue number 1. Like I said, in order to uniquely identify my file, I'm using this, its address. But that doesn't identify the entry itself. Now we need to modify the entry itself. If we want to modify the file itself, we can just use the address directly. So easy. If we want to use this, that's not going to be so easy anymore. So I'm not sure how to handle that. You're fixing a TV, nice. Well, if it's an old TV, nice. If it's your normal TV that broke, I hope you can fix it soon. Alright. So that's kind of issue number 1. in which we can't just go here and be like, this is the entry that we're going to modify. But I am keeping the path of the entry, which is really the best we can do, is the path that we used to find the entry in the first place. So we go through. Ooh. Do we have the name of the file that we're opening? It's called fattest. It's supposed to be fat test, but whoops. Yeah, just keep track of the file path, and then what we're doing in order to find the file in the first place is going through each of these and finding their correct place in the disk. Now we're kind of gonna have to do the same thing when we want to modify the entry itself.
Followed your channel.
Which kind of makes the whole serial number a little bit useless, because we still need to go through this entire thing. It's not amazing. I'm sure if I tried to optimize it, I could optimize it a little bit, but frankly, IDGAF. So that's issue number 1, is finding the file entry that we're going to modify in the first place. But issue number 2 is writing the file entry that we're going to be modifying in the second place, I guess. Writing to it and then writing it back to the exact place in memory where it's supposed to go, which may or may not be the top of the list. Because FAT32 works with clusters, which are 512 megabytes apparently, in this current implementation. Other implementations can have different sizes. So they use 512 bytes per cluster, and your entry can be in the first cluster of the directory, or the second one, or the third one, and you need to write to the correct one, which I currently don't really have the ability to do. So I have to fix that. I'll have to consider how to do that. But yesterday I was a little bit too tired to do that, so today we're gonna have to do that. Soldering 2 pieces together, they were 10 pounds from AliExpress. That definitely doesn't sound worth returning. So yesterday I implemented the file writing itself, but like I said, we're now modifying the entry, so it's not really worth much because we're, kind of how do you say it? We're unable to change the size of the file. If we don't change the size of the file, we kind of,
257.358 followed your channel.
I'm blanking on what I was going to say there, but yeah, if we don't modify the size of the file, we get the issue that I showed before. So, I'm not sure how to handle it, honestly. First off, I have this, list directory here that is one function that recursively goes through a directory. Then we have walk directory, which is another function that recursively goes through a directory. And actually, the list directory relies on that. No, really. Now, it just creates a list from the directory. So no, it's a different thing. I'm not sure how to handle this in the best way possible. Most likely, what I want to do is I want to create a new function that goes through a directory and does all this logic, but is actually capable of modifying an entry. Or all right. Here's the deal. So walk directory can already handle the logic of traversing a path until it reaches a specific file or folder that it's looking for. And when it does, or actually each step of the way, it is going to call this handler, whatever we pass in. And that's where we check, is this the one that we're looking for, and how to handle that. But it doesn't technically modify the entry. It cannot do that. But I think I can adapt it to do it. That's probably the best thing I can do, so I don't reuse this logic a million times. I don't copy this logic a million times, I mean. So I'm going to start off by adding this functionality to truncate, which is the function that just explicitly changes the size of a file. We're not supposed to call this function explicitly necessarily. We should also want to do it when whenever we write the file to disk. We also want to do this. And essentially update the entry to tell it of the new size of the file every single time we write the file. But I don't have that functionality yet, so for the time being, I am explicitly calling this function that sets this file's size to this size here. So I'm just going to use that. So that means I need to create a new handler. I'm just going to reuse the one that I already have here. Trunk entry handler. And I'm going to have to modify the signature of this a little bit, but we'll get to that. Let me first implement it. So right now, really all I'm trying to do is change a file size. That's literally it. Change a file system entry to reflect the new file size. All right, so trun entry handler. All right, so what the truncate function does right now, this I did right yesterday, is you pass it a file descriptor and it retrieves the file that points to, including the file's path. It then uses that path to walk the directory, calling this handler every step of the way. And what are you complaining about? It's not saved. That's why it didn't match. That's not it. Oh no, yes, that is it. Okay. Alright, so the handler is going to be kind of similar to the read file handler, which is another similar, this one. Another similar one that simply goes through the file system until it finds the correct file that it's looking for. I think actually most of its logic stays the same. Yes, its logic stays the same. it does this check here that, again, I'm not entirely sure what it means. Just if something is marked as being a volume, we kind of ignore it because it's a volume, not a directory, something like that. I don't remember exactly. But anyway, what it does is it's given a file system entry, so that whole super convoluted thing that I mentioned before, matches the file name to the one that it's expecting to find, which is either part of a directory or the file name itself. So first it does that with this, then with this, then with this, until it matches the full thing. And does a bunch of logic for that. And finally, the important part, if the entry is a directory, then that means that we're going through, boot, write-os, hello. It means we're at this entry, and we just gotta move on to parse the rest of it. Same thing happens here. Whereas hello is a txt file, so that one is not a directory. This is just a safety check, and then here is where it should be modifying the size of the file. This is where it gets a little bit complicated. Because here we have the entry. We want to modify the entry with the new size, then write it we want to write it to disk at the correct place. That is the part that isn't amazing of this entire thing. Modifying the entry is the easy part. We just do this. File size equals some new file size here. It's going to be easy. The question is, where do we hold the file size? Since this is technically a function pointer being called by this, usually in C you would use something like capture groups. It's not amazing. But we're in C++, which makes me wonder, can I just capture? Can I just do that? As in, take your time, Firefox. You need an adapter. Oh. No, thank you. Never mind. What's the point of C++ then? The one feature that it has that C doesn't, which is lambdas and closures, is useless. It doesn't fucking work. I guess that is the point of C++ being useless. I'm just gonna do something else instead. I'm trying to keep the code as clean as possible. Here's what I'm gonna do. I'm going to create a new structure, and I'm gonna call it FAT32 entry attributes, and in that I'm just going to put a U32 file size. And I'm going to modify walk directory to also take in one of these. And then I'm going to modify this to also take that. Ideally in that order. F32 entry attribute where we set the file size to the size requested. And we're only allowed a 32-bit. So we have to mask it. Non-constant expression cannot be narrowed now.
Highas Gauch followed your channel.
What in the name of fuck are you talking about, C++? I hate you so fucking much. Die already. What are you talking about? You cannot do this operation. Who do you fucking think you are? You failure of a language. I will literally take 10 minutes to replace all of this code with C code. It will literally take me 10 minutes if you don't fucking behave. What is going on? Why is it so difficult to initialize a structure? Like, what is your problem? Does it have to be a constant? It has to be a constant. You're joking. What a joke of a fucking language. Clearly, I'm not in the mood for FAT32's bullshit today. Not FAT32, actually. C++ is bullshit today. Neither. I'm not in the mood for either of them. So, I feel like C++ claims to fix a bunch of issues in C. Really just introduces new issues, while not really solving the ones that C has. So what's the fucking point of this language? Why waste our time with it? Where does it go in walk directory? Here it is. It's the last. Pass the modifiers there, pass the modifiers there. Still about a million different errors going on. Alright, so here I pass a 0 because we're not modifying anything, so that makes sense. Then and there. Alright, that should compile this godforsaken language. Hello, Dev. So again, to modify the entry, all we need to do is just modifiers file size. And actually, we can do this a little bit nicer If we're supposed to be modifying the file size, then we do that. The question is how to write it back to the correct place in the disk. We don't really have logic to do that yet, so we'll have to add that. Why is this commented out, by the way? Pretty sure I can just do this, and then can you not be useless for once in your fucking life, C++? I don't know why I'm hating C++ so much today, but it definitely deserves it, so I don't give a shit. Entry, file entry directory, that's what I want. Okay, so here you put entry directory, otherwise you put entry file. That should be easy. Don't understand why I commented this out and didn't add it in. Pretty easy to read attributes from a file. Now that we can just access the file system entry directly. Writing is another thing. Again, we just added this whole logic to be able to modify using this modifier with a hard-coded file size, by the way. I completely forgot about that part. Because C++ is fucking stupid. It somehow didn't let me do that before. There. I can now set a modifier that is going to be called on this entry, and I don't even need the modifier. That whole thing might have been useless. Yeah, it was kind of useless. Well, not really, but maybe. This walk directory already returns an entry. Again, the question that I have is then, how do I know where to write this entry back into the disk? That is the question that I can't really answer. That is a question for which I do not have a proper answer, as a matter of fact. First off, I need to find the exact place where the file was modified. Like where the file is stored. Not the exact directory, but the exact place in the disk. And then I need to replace only that. And you do this in sectors, so I need to do it in chunks of 512 bytes. So what is the best way to do this? Again, I could get rid of this entire handler thingy. That would be cool. It would definitely simplify the code by quite a lot. It would get rid of 3 nearly identical functions. But The problem is walk directory goes through where's the increment for this? I see. Goes through the file system entries one by one using their size, and it doesn't really keep track of which cluster they each belong to. So that's a little bit of an issue. I don't really have a way of keeping track of that in any way, shape, or form. So that sucks. All right. All right, here's what we're going to do. Walk directory. Where is this being called again? Inside of one of the handlers, because they're recursive. When you're opening a file, you walk the directory. Again, inside one of the things. When you list the contents of a directory as well, that makes sense. There are essentially two entry points into the driver, one for reading files, one for reading directories. Makes sense. When you're reading the properties of a file without opening the file or do anything like that, so it makes sense. And when you are truncating the file, which again, very similar operation. This time you're just writing to the file entry, so you need to walk the directory to get to there. Hello, Crispy. Okay, your name is blue and the background is blue. It was a little bit hard to read. So I could get rid of these handlers, but they're really not the problem. The problem, I think, is what walk directory returns. It has no way of tracing back the entry that you have to the exact place in the disk where you got it from. And I don't think that there's a better way to do it other than just to save that information somewhere. Now here's the funny thing, there are some reserved areas inside the file system entry, but I don't think I can change any of them. There's 8 bits reserved here. And nothing else. So that means I probably want to have a... Okay, here's the thing. Again, this whole, like... Can I just undo all the work that I did today, actually? Because, like, this new structure that I added now, that was definitely not the way to go. I added it to all those places. Now I need to remove it from all those places. So yeah, I can undo everything that I did, keeping only the work that I did inside the stat function, because again, this is technically already implemented. So let's ignore everything that's happened in the last 44 minutes. Hello everyone and welcome to the stream. First time streaming today. Welcome everybody. Alright, today we're going to work for the first time on FAT32 stuff. We're definitely not starting over, we're doing it fresh. Alright. That color works a lot better, yes. So, alright, we actually just implemented, just by copying and pasting, this stat function. So, pretty cool. Which, by the way, should return a true or a false if it doesn't find the entry. Or if there's no entry file size, we can assume that that failed. I didn't just start a stream though. I just undid all the work that I did, so I'm pretending. Alright. Anyway, Here's the cute thing about these handlers. I've pretty much removed the need for them. The read entry handler was supposed to recursively go through the directories until it found the file that you're looking for and then open the file, read it, and then give you a pointer to the data that it read. It doesn't do that anymore. Now when it's done, it just returns the file system entry itself. So we don't really need it to do that anymore. And we can just use it here. Even though we're not really reading an entry, it doesn't matter. And again, we're probably going to be able to just move its logic into this function and get rid of it entirely, but that's definitely not a priority right now. Either way, calling this function with this handler is going to give us the file system entry for the file that we're trying to truncate. Then all we need to do is just replace the entry's file size with the size that we're given. We're going to use a uint32 mask because we're only allowed 32 bits. So I hope your file isn't bigger than like 4 gigs. There is technically a maximum file size because of that. And then that's it. We've modified the entry. But again, we have the problem of we need to write it back to the disk. We need to access the actual disk and write that information there. And we don't know exactly where we need to do that. So I'm thinking of just modifying walk directory to tell me that information. Where in the disk is this information supposed to go? Just do that, and instead of returning a FAT32 entry, you're going to return a structure called a F32 walk result structure. And that is going to contain an entry, and I think we can actually just like get rid of the allocation, so if we just don't make it a pointer. The entry and the cluster where the entry is, and maybe even the offset into the cluster. Do you find programming difficult to grasp at the very beginning? A little bit, yeah. The logic of it, you have to figure out. But I feel like once that clicks, everything else gets a lot easier. But yeah, at the beginning, a little bit. Alright, so now, walk directory is again going to walk a directory until it finds the file or folder that we're looking for. And what it's going to do is it's going to give us the file system entry, so the ridiculous structure that FAT32 uses. It's not going to give us the file name until we need it, because that's a whole other story that I don't want to deal with. But yeah, it's going to give us that. It's then going to tell us where in the disk that is located in terms of cluster, which again is a group of sectors, and a sector is 512 bytes. I looked yesterday, in this driver, a cluster is 1 sector, so really a cluster is 512 bytes. But I don't think that's always the case. That's just the case for this image that I'm using. Otherwise, what's the point of a cluster? Like, why would you have a concept of a cluster and a sector that are separate, but then they're exactly the same? Then again, it was designed by Microsoft, so there is a possibility that that's actually a thing that they did. And yet, well, let's see, I feel so drained by the act of learning due to AI. What about AI though? You can kind of just ignore it. You're kind of way better off ignoring it. Alright, so it's going to tell us, essentially, the file that you requested, this is the data that we have on it. This is where we got it from, in terms of the general area where we got it from, and the offset into that, where we got it from. So that means we are going to go, in order to write the file back, or to modify the entry and write that back, We're going to go to the sector, we're going to go to the offset, we're going to overwrite that part, and we're going to write the entire sector back to the disk. Okay. So walk directory is now going to return that. Where are you? Here. You don't return a structure, a pointer anymore, you return that. Cool. So that means I need to modify all of these things, but first we start by modifying this, the walk result. All right. So pretty sure if we just return an F32 entry, no, not entry handler, walk result like this, we should be able to return data directly. Super sticker, thank you for the super sticker. Czar pair character punching the air with fist and bump written on his knuckles. I love how incredibly detailed the explanation is, but then it can't actually render it. But it is on YouTube chat, so thank you for that. All right. Funny thing is we need to calculate the cluster. And we need to calculate the offset into the cluster. But we're then going to return them like that, nope, like that. And the entry itself, we can copy from found entry like this, which I believe really it's just a mem copy. I think that's, I hope that's how it works. So we return that. No, we can't directly return it. Because we need to do this. Okay, it's a little bit more than I expected it to be. We get the entry from the handler, and the handler can needs to return something else. So, all right, I'll have to make more changes than I expected. I consider NeoVim, yes, but I like the mouse. Turns out it's useful for text editing. Almost like I was created for it. Almost. And for like precise manipulation of the screen. Almost. Alright, so actually this handler, we can fully get rid of it. We don't need it at all. Pretty sure we can get rid of all of them, but again, not in the mood for that right now. F32 walk result, that's what you're gonna be returning like that. No. No. You return an entry just like normal, yeah. No. I'm so lost. Yeah, no. They need to have the same return type as the other function. That's kind of important. I feel like I don't like the code that I'm writing, but whatever. All right. God, this code has gotten so much worse. Okay. Jesus. There. Okay. So now we need to replace all these return zeros with return empty structures. Like that. And like that. And like that. Okay. So now again, walk directory is going to tell us exactly where it found the entry that it's returning. And for that I had to modify half my code again. And I'm not done with doing that. So you actually need to return a result, which can be 0 in these cases. Otherwise you just return something like this. Then when you open a file, you don't get an entry. You get a FAT32 walk result, walk result. You get the entry from the walk result entry. I can just add a success thing to this. There are better file systems, but unfortunately we don't get access to them. Yeah, there's no reason this needs to be a pointer anymore. This returns found true, and the other function that I just modified, this one, found true. Actually, we can thank the Raspberry Pi for using this goddamn file system. Stupid as hell. Anyway, keep modifying code. Now we return a result. So here, 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 and here.
Ruinivist followed your channel.
We failed. We return empty. Otherwise, we return not an entry. Rather, we return an entry that has this value. Cluster 0, offset 0, found true. Hello, Ruinist. Got an equal sign there. And then here, we don't do this. We instead get an F32 walk result. And if... I just realized I didn't have a null check. Turn 0 if we failed. Otherwise, we get the entry from walk result entry. And we don't get arrows anymore. The rest actually stays the same, surprisingly. All right. So that almost worked. We're almost done. We can simplify the code a little bit by just doing this. It always returns a value. Nah, don't feel right doing that. Okay, there we go. Is that all compilation errors? No, we have one more for the thing that we're actually trying to modify. F32 walk result. If no result found, return false. Result entry file size becomes that. And then here we can call a function that we're going to call it that. Write section to cluster. Write section to cluster. The cluster we get from result cluster. The offset we get from result offset. What we're gonna write we get from result entry, and the size of it is the size of a FAT32 file entry. So what this is going to do is it's going to write the section that we're trying to write back, so just the entry, by getting the entire cluster, modifying just the area that it's supposed to modify, and then writing the whole thing back. I think we have to do it by sectors at the very least, so we kind of, it's the best we can do right now. But, okay. I think all the code is there except for the part that calculates which cluster and which offset we're currently on. Now, this is where it gets a little bit complicated again. Because FAT32. Honestly, this part about FAT32 is probably the one I like the most. The actual FAT file allocation table. That's what FAT stands for. And essentially, the way that it works, also kind of mentioned it yesterday, we have a table. Where do I even store that table? Here it is. It's a table called the FAT, where it's kind of a linked list in a way, where several a big file or a big directory is going to have multiple clusters worth of data. Anything bigger than 512 bytes in this specific one that I'm using is going to have multiple clusters. In order to get data from multiple clusters, we look into this table. From the start cluster, use that as an index into the table, it points us to the next cluster. Use that one's index and it points us to the next cluster. Convenient. And it technically means we should be able to recompile which cluster we're currently at by just defining, here it is, the cluster size cluster size is in sectors. Sectors are 512 bytes, so this gives us the size in bytes. And I is plus equal the size of a FAT32 entry. So actually, the cluster index, so to speak, is given to us by just I divided by cluster byte size. And the offset is given to us by the remainder of this operation. Right, so it should really be that easy to calculate the index of the cluster that we're currently in. Now, that's an index of a cluster. That's not the actual cluster. The index of the cluster based off... Oh, can't find it right now. The root index, which is the first cluster of this directory. I need to calculate where the actual cluster is. This is, again, a cluster index. This is the offset into the cluster. To calculate the cluster, I'm going to create a new function called resolve cluster index using the root index and the cluster index. Just gotta make sure that root index is the correct value. It is. All right. So what's this function going to do? It's going to give us back a cluster value based off of the root index going to be very similar logic to this thing. Best resource for OS. I don't know about the best resource. I wouldn't even call my own videos that. But the OS Dev Wiki, as well as I guess my own videos. Though they haven't really updated them in a while. But OS Dev Wiki is probably a good starting point. Alright, can I make this logic a little bit better? Essentially, we're just gonna go through the linked list, kind of. Like I said, it is somewhat of a linked list. We're gonna go through it until we reach the index, and that's gonna tell us the pointer that we want. Where currently the entry is stored inside of... Yeah, that's not correct. Hold on. Let me rewrite the whole thing. We're going to go for int I equals 0 until I is smaller than index I plus plus. And you're going to complain because the compiler's a little bitch. There we go. Yeah, actually, all we're going to do is this. Next equals to fat next. And that. Alright, so just iterate through the list until we've iterated all the indexes. And then we want to check that if next is equal to 0 or next is bigger or equal than this number, then the whole thing probably failed. We want to return 0. Once we get here, next should contain the index that we want. I mean, not the index, but the cluster itself. So what does that mean? I have a chain of clusters, and I want to get cluster index 0. Starting with start, I want to get the 0th one. It's a weird number. Next currently contains the 0th one. It doesn't go through this loop at all, and it returns the correct value. What if I'm trying to get index number 3? Alright, currently contains the 0 one. Indexing into the table with the first one, or the 0th one, gives me the index of the next one. I check that it's a valid index. If it isn't, then I failed, because I still haven't gotten to the one I'm looking for, and I got the end of the table, so something went wrong. Otherwise, if it is valid, I just continue doing the same thing until I reach the index that I want. At which point, next is going to point me to that index. Yes, I think that is correct. Alright. And now the last thing I need to implement is write section to cluster. Funnily enough, this is going to need some kind of similar logic. To what I just did, to go from a cluster to a sector. Again, the disk works with sector. A cluster is one or more sectors, but they're continuous in memory, so it makes this whole thing a little bit easier. Sectors per cluster, okay. What just happened? I wanted this, and it butchered the code that I was writing. I don't know what happened there, but whatever. Okay, so translate the starting cluster, the starting sector of the disk to from the cluster that we're trying to write. Which, right now there's actually only one sector per cluster, so this whole thing won't even do anything, but it is still good to write. That gives me the beginning of the cluster. But I want the beginning of the sector, so I can only write 512 bytes whenever I need to write 512 bytes specifically. So sector, on top of that, we're going to add to it the offset divided by 512. And that's where we're going to perform our disk read and then disk write, but not yet. I want to check, essentially, that the end of what I'm trying to write is also within the same sector. Otherwise, I'm going to not be writing the full thing. So to do that, I can just check that if offset plus size is bigger than 512, then I can assume that I need to write 2 sectors instead of 1. I'm hoping I'm not writing something so big that it requires me to write multiple sectors. Yeah, I probably need to do that. All right. So we're going to read as many sectors as this tells me, starting here. And we are going to modify some data. And we're going to write that back. So we're going to do a disk read. Oh wait, that's not how we do that. Hold on. All right, first off, we're going to initialize some memory. That would be 512 times the sector count. Then we're going to read into it, starting at sector with sector count. Then we're going to mem cpy into this data plus the offset. What are we going to write into it? We're going to write the buffer, how much, the size. So now we read a certain amount of data from the disk. We modify it with the data that we're supposed to be writing. And then we can just disk write, again, the same data to the same sector and the same amount of sectors being written. And sectors are continuous, so we don't have to deal with any weird stuff there. And then we just return true. Did any of that fucking work? It's a very fair question that I'm going to ask myself. It would be really funny if it did. And it really says a lot that I think it would be funny if my code works. Not good, not fortunate, not even my skill. No, I'm just saying it's going to be funny if it works. That's reassuring, really. As the person who's writing the damn code, it's really reassuring. It didn't fucking work. Well, that makes sense. See, I would have been very scared if it works, because, like, what do you mean I wrote all that on the first try it worked? I barely even know what I'm doing. It was my first time writing to disk. This is literally my first time writing to disk. Besides when I wrote this initial disk write function, and then I wasn't even dealing with file systems, I was just doing raw data. So, hey, we've come a long way. Alright. So, let's put some prints. Okay, print. Okay, printf actually. Entry. file size now, and you're actually going to print the result entry file size. Cool. Then actually you can tell us exactly where that is supposed to go, and I can go and verify that if I want to. We'll write back data to actually tell us how much the data that you need to write back is and where you will write it. So that that's not supposed to be an equal sign, it's supposed to be a plus. So what does that mean? You're supposed to write the size of a file32 file entry. So not really much of a point to logging that. We can literally just do this and see that it's 32, but whatever, it works. Where are you going to write it? To the result cluster plus the result offset. Like I said, there's that whole calculation that I'm doing to transform a cluster into sectors, but luckily there's only one sector per cluster in the current implementation, so again, that's up to the library that I'm using to create the disk, so who cares? None of that printed. So hey, that's already kind of a start as to why this didn't work. Somewhere along the way, we'll truncate S to X path size. I'm trying to write to disk. That's literally it. That's literally it. Alright, so is this function being called? Because it feels like it wasn't. Actually, I don't need to modify the file. I just try to save it, and it says we'll truncate empty to 0xb. Okay, so that's the problem. File doesn't exist. I mean, not really, just that the file name isn't being assigned properly, so that's not really helping. I see. Let's make this a string. The M file. Module file. This char pointer, I'm gonna make it a string. And that way, I can copy it. Because that's kind of a thing that I'm not doing. I'm sure it actually exists here, but it probably gets wiped by the time that I actually use it. So it doesn't work. String from literal, bada bing. And then I gotta use it here. Data. Data. That should work.
Ilfat__90 followed your channel.
I am on a VM first. Technically, it can also run on Raspberry Pi, but having some driver issues with one of them. Haven't tested it on the Raspberry Pi 3 in a really long time, and the Raspberry Pi 5 is a mess. Oh, actually, the entire Raspberry Pi is a mess, so not exactly in love with that whole thing they got going on the Raspberry Pi, to be completely honest with you. Don't I have a string match equals? No, I don't. Yeah, my middle name is Claude, actually. Okay, now it actually has the name of the file, redOS fat test, found and modified an entry, file size is now 0b, we'll write back the data to this sector, which looks correct, times x80, saved file. Allegedly. Oh, tiny issue, I didn't modify the file, so how the fuck would I know? It did not modify the file. Alright. So it told me that it would write the file to this sector here, well, this cluster here. Let's continue adding logs. Will modify, no, I don't use CLUD. Sectors starting at XX, okay. So tell me how many sectors you're going to modify. I expect this number to be at least 1 because I'm sealing it. I had the same issue yesterday where I wasn't using seal for an operation and that was lowering it to 0. But I learned my lesson. Starting at sector, and then sector times 512 is going to give me the exact byte from which we start writing the data, which I can go and check. At the very least that I'm doing the calculation right. We'll modify one sector starting at this with this number here. Alright, so let's begin with that. We're going to go to OS, disk image, open with ghex. And we're going to jump to byte 0x27 and jump in there, we see that it is a garbage. Absolute and other garbage. And the scrolling has actually completely messed up where we were. So can you do that again, please? I mean, not scrolling, resizing the window. Has completely messed that up. Where is that? 27800 here. Funnily enough, kind of. No, wait, no. Hold on. How many bytes is that? Yes. I'm doing it right. Okay. I'm modifying the sector of the disk, which contains the entry. We can tell because it has the word fattest in it, which is the name fat test, which is the name of the file that we're trying to write. So technically, yes, it is there. I think it looks to me like the fattest is there. Also there. What am I doing? Long story short, we're trying to write a file. That's it. We're trying to save a file. That's the entirety of the last 48 hours of my life. 48 is a strong word. 24. In order to write a file to disk, you need to write the actual data of the file. You need to handle what happens when the file gets bigger or smaller than the amount of data that is allocated for it, which is a thing that I'm not yet handling. So I need to do that too later. And any file system is going to have some sort of entry, which is like a pointer into the data, and you need to modify that as well because it has some information about the file which is now out of date. In this case, what I'm trying to modify is the size of the file. Right, so the file is this one, fat test. That's the only way that you're supposed to read this. And then this is the file entry. I don't know exactly what it is supposed to mean. But in order to write this, we need to actually access the disk in like 512 bytes at a time. So what I'm doing is I'm reading 512 bytes. I'm modifying from that the ones that I need to modify, and I'm writing everything back. Did that work? We can quickly check what that data that I have selected is supposed to mean. It's 11 characters for a file name. 2, 3, oh wait, it's 11 characters, yeah, 8 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Why is there a bunch of 20s at the end there? I'm not super trusting that. But that is 11 bytes. Anyway, after that comes some flags, which come in a 8, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then there's this. Then there's this. So these are the flags, and this is the reserved value. Then a 10 millisecond increment for the timestamp, and 2 bytes for the timestamp, 2 bytes for the timestamp, 2 bytes for the timestamp. Data is found here, and then skip here. 013F38 looks like the address for the correct address for the file, followed by 0D 0000000, which is the size of the file. I think that means that this whole thing is 32 bytes. And that is the file entry. Okay, so this is what it looks like. Here's what I'm gonna do. This is what it looks like after I've tried modifying the file. And every time can I copy the hex, please? When I copy from here instead of from here, can you copy the hex? God, this program is a little bit... piece of shit. Now, the file format is FAT32. I wish it was exFAT. exFAT is, at the very least, still the same architecture as FAT, but better. It's not good, but it's better. Okay, I want to copy these bytes. I want to copy the actual byte values. How is there no way to do this in a hex editor? In a hex editor, you cannot copy hexadecimal values. This has got to be a joke. Bigger than C++. Okay, maybe there's a paste. Bullshit. Can I open a new tab and just paste it in here? That's the best I can do right now. Okay. That works. Alright, so I'm going to restart the operating system, and what that's going to do is it's going to create a new disk image from this folder. So essentially reinitialize... I left the stuff that I wrote. Where did I leave it? 323. What are you complaining about? No, what are you complaining about? Excuse you? Okay, I must have left some garbage in one of the files that I didn't realize. Anyway, now we've actually recreated the file. So I can go here and... I forgot. The exact address. What? Driver for the ARM A2 architecture? A driver for the architecture? What do you mean with that? Okay. Here it is. And it is in a completely different place. It's in a completely different place, so that is the problem. I'm calculating it wrong. In the non-modified version, this is the address 2903880. In reality, it starts reading here. It should read all of this, 512 bytes from this, then replace this entry, this line here, with... Where's the other thing that I had? Did I close the whole thing? Oh my god, what a shit program. So, I was using this disk image. Then I opened a new tab and I wrote some data into it. And then I closed the image, so that closed the new tab as well without saving it, so I lost that. But whatever, it's supposed to override this part. But instead it overrode the entire thing in a different address.
Daikazas followed your channel.
Which I did think it was kind of weird that this entry was there by itself. It makes more sense that it would have this, which are other files around it. Also, this is what the FAT32 names look like. Like this. It's ridiculous. First off, there's a dot in between every character because it's 00. Just to indicate that there's 16-bit characters, whereas I'm rendering them as 8-bit characters, so that's why there's zeros in between. But then the way that you're supposed to read it is you're supposed to read this part, then another part, which is not here. Then here it tells you the file name in this format. It's ridiculous. It's really poorly designed. No, the OS architecture is ARM 8, I think. Whatever the Raspberry Pi uses is 8, I think. So yeah, here we go. This is the actual ridiculous redacted conf ig. Redacted config becomes redacted config. Insane fucking file system. Anyway, back to the issues that I'm having. I said we'll modify certain sectors starting at this number, so this number is wrong. I had the exact same issue yesterday. I don't remember how I solved it. The whole thing is designed for ARM, so what little assembly you even need for an operating system is all in ARM 64. I'm trying to remember how I solved the issue. Like, there was a math issue yesterday that I solved, and I don't remember how, and I was doing a calculation wrong. Can't really control which file system I use, though, because the Raspberry... Well, I could, kind of, in a way, but not really, because the Raspberry Pi uses a FAT32 in its bootloader, so it needs the boot partition to be that, and then on top of that, it also has ext4, but I'm not using that partition. I can't be bothered. I've seen the way Linux does file systems, and it's fucking ridiculous. Not that this is any better. See, the thing is, like, I like the way that FAT is implemented. Designed, I hate the way that it's implemented. Whereas for any Unix-like file system, it's Unix-like. I mean that as an insult. Alright. So the issue that we're having is we're writing at 2707800 when we should be writing to 29 something something. Why? Why are we doing this? Ah, the data offset. That is what I want. That is what I want. Right, so that should give me the logical sector address. I still don't remember what LBA stands for, by the way. It's logical something address. I don't remember what the B stands for. Alright, now it writes to 2903800, which I believe is the correct place. It definitely looks more correct. Let's see, if we go to 029838800, it might be correct, but it definitely overrode everything else because there's a bunch of zeros here. Alright, 0903800. When I just restart the operating system, I'm wiping all the changes that I did. I can open the file again, go to the same address, 2903800. Yeah, this is the one. This is the sector that I'm trying to write. I'm trying to write 512 characters, which is what, 0x200, I believe. So, this many? A little bit more than that. But somehow I'm only writing this part. Everything else is not being written, which means I'm deleting like half the files that are there. Whoops. Not bad. I hate when that happens. Um, I wonder if it has to do with this. We're supposed to be reading into this buffer from sector to the amount of sector count. Instead, we're doing sector count in both cases, so we're never reading the data. Not correctly, anyway. We're reading data from the very beginning of the disk, if at all. Alright, I forgot, I don't have delete implemented. Boom. I'm not sure about open source file systems. A lot of the one I looked into several, and it's like they seem very Unix-like. And you just look at the definition and it stinks of Unix, and I don't like that. Alright, drive. I don't know what the DTBs folder you're talking about. That's nothing. That's just device file trees that the Raspberry Pi provides, but they're not useful for anything. I don't use them at all. You have to use a toolchain, the ARM GNU toolchain to compile this thing. The one for ARM Arch 64, bare metal. Okay, so I think we're good. I think it's implemented. With again, the tiny little issue that I hadn't even considered this whole time. I hadn't thought about this. The disk image is created from this folder. Every single time you run the system, it will recompile the disk image based off of this folder. Which means anything you write to it will be overwritten by this folder. And it's not like I'm, mirroring the changes back. So it was all kind of for nothing. Every time you run the system, you're gonna override the changes that you made. I mean, you can disable that. You can just I think it's the make file that does it, yeah. Just not create the file system. And then that shouldn't happen anymore. I do have my own compiler for that matter. There you go. It already doesn't happen anymore, so there. Now it's technically not going to be synced to this folder anymore. So if you make changes to this folder, you'll have to make changes to the file system, kind of. Another thing you can technically do is, can I just mount this? Yeah. And just make modifications to this directly. But yeah. Thank you for that notification, very useful. One for running and one for running and setting up. No, there's no need. You can just run the create fs separately. The command is already here. You just have to run this. If you want this folder to override the disk image. If you instead want to handle the disk image yourself, just don't do this. Also, another interesting thing, I think this is only has to do with disk images. You have to use a power of 2 size. So you can't do a disk image that's like 13 bytes. It has to be... Well, I think the minimum is going to be like 64 megabytes. Or maybe I'm making that up. But you kind of have to round it up to a power of 2. Something like that. Anyway, I guess I implemented file writing. That's cool and all. I hope, anyway. I mentioned there was one more thing I needed to do, and I already forgot what it was. Right. Essentially, where is... write to file, I believe. Write file, then calls write to disk. Okay, this. We need to do this. When again, all has to do with the FAT32 table. Well, not the FAT32 table, the FAT table, the file allocation table, the actual table that gives the name to the file system. When my file grows too much, I need new clusters to write into, so I need more space for my data, and then I'm going to find them. All right, so I have this logic here that checks if the new cluster count is bigger than the old cluster count, or if it's smaller than the old cluster count. We'll need to allocate new clusters in this case, or truncate, so free up some clusters so that they become available for the next whoever needs them. Right. So I'm going to create two functions for that. alloc fat u32 start u32 count and free fat u32 start u32 count. Not sure about the free function. I don't know. Not entirely sure what the intermediate representation has to do with low-level programming. But sure. Anyway. Don't you feel a bit overwhelmed with all the info on your screen? Not really. I mean, I know what I need to look at and what I don't need to look at. So I don't need to read most of these logs, for example, so I kind of just ignore them. I keep it open because I'm always like going between, but if I wanted to, I could just do this. For the code, I have to say, syntax highlighting helps a lot. If I didn't have that, I'd probably go crazy. Can I go just plain text? Yeah, I find this a lot harder to read. Whereas instead, if I just do C++, at the very least, I can kind of see, you know, this is a function call, this is a function declaration. Everything is purple. But which is also a more muted color than white. That kind of helps. And this part I'm not looking at most of the time. I just don't like opening and closing windows all the time, so I keep them there, but I kind of just ignore them. You kind of get used to that, honestly. In the end, there's not that much information going on because I kind of tune it all out. Literally, all I'm looking at is this and this. And I'm actually not even looking at them, I'm just thinking about how to implement them. Okay, so we're going to call it truncate fat and allocate fat. Can I actually just make them the same function? Resize fat. Alright. So literally, just do this. Resize fat using the root index and the new cluster count. Alright. It is my own OS, yes. So, kind of reduces the logic to, we have the file size from before. Well, the number of clusters, not the file size. It can be different, but the number of clusters that were being used and the new number of clusters that's going to be used. If that's not the same, we'll need to resize in one way or another. So let's implement that. We will need an allocate function, but Okay, if no fat or start is smaller than 2 or start is yeah, that logic can stay. We'll just need to put it like this. Okay. Hmm. Let me see how I can structure this. If I'm allocating, I'm going to need to go through hold on. You know what? Let me get some water because I've been talking for like 2 hours and I don't have any. And run an ad that's coming up anyway and do this afterwards. Okay, we're back. And by the way, TCP from scratch is a pain in the ass. It sucks. Not doing it, just TCP in general. Alright, so alright, so the problem at hand, we want to resize an allocation of FAT32. There's a few ways that I can handle this, but honestly I wouldn't mind handling it like this. Wait. I need to write the fat table itself to the disk after I do this shit. I forgot about that. Alright, so here's the thing. We're just gonna go, when we're told to resize fat, we're just gonna iterate through all the clusters that we have until we reach the number that we want. And then we're going to check the next. If the next one is 0 or this number, then we're not going to return 0. That's not an error anymore. What we're going to do is we're going to allocate. So we're going to do fat next equal to alloc fat. I'm going to rename it to current instead. Next. Okay. No, no, wait, why am I doing that? That doesn't really change anything. That was completely unnecessary. What I wanted to do was this. I keep track of the new cluster, and we're going to use that one as the next one. So that way we're allocating new clusters. But what about if we want to free clusters? Well, U32 dialog. We're just going to create a function called dialogFat, which is neither of these are actually declared properly. I'm not sure why I'm returning -1. It's not even technically a correct value, and it's just a placeholder, but I don't know what I'm doing that. So essentially, if we get to the end of the chain of clusters that we are expecting to read, or that we're expecting to use, and there's still more data after that, then we're going to need to get rid of that. How do we get rid of that? By deallocating. No, this actually doesn't need to return anything at all. Just needs to return, that's all. All right. We're going to call deallocFat on this thing, pretty much. And then we're going to set the fat for cluster to 0. Is 0 the correct number? I don't know about that. I don't think it is. I think if anything, the correct number is this one. I'm not even sure. But kind of want to run through the logic real quick. Oh, and I haven't implemented this yet. All right, so we're told to resize. We have a chain, which already has its own size, but we don't know it yet, and a new size that we're expecting to put in it. So we go through the chain until we reach the full size that we expect, the new size. And in the process, we start at the current cluster. We check the next one. The next one we take from the current one, indexing the table. And if the next one is 0, or the next one is bigger or equal to this number, then there isn't a next cluster, but there's supposed to be because we're inside of this loop. So we allocate a new cluster, we set it inside the table, and we point to it next. So we continue doing this thing. All right, so allocation looks fine. Now we reach the end of this, which means we have as many clusters as we need for this file, but we could have more than we need if the file got smaller. In that case, next will now point us to the last cluster. The one that is supposed to have 0 or this number as the final number, as the entry in the table. If the entry is anything other than that, then we need to deallocate. When we deallocate, we check if it has a valid entry. We first deallocate that until we reach the end. So essentially we're going to continue down the chain until we reach the last element, and then we're going to write empty in each element going backwards until we reach the one that already isn't supposed to have a next one. So I think that is correct. Now what I need to do is check again this number. The FAT32 spec, I believe, is officially held on like GitHub. So hopefully Wikipedia has enough information for what I need. All right. Last cluster in file. File system implementations must treat all these values as end of chain markers at the same time. Most file system implementations use this as end of file markers when allocating files, but versions of Linux use FF8, FFF8, or 0xFFFFFF8. All right. So any value between something and FFFFF8 and F is technically considered to be end of file. So yeah, I can just write that. Though that's the way that Linux does it. Not me. Not me. So at the end, I'm going to be writing this. Wait. No. I need to write 0. And then fat next is going to be this thing. All right. 0 means free cluster, whereas this means end of cluster, end of chain, technically. Now, to then allocate a new cluster, all we have to do essentially is just go through the free clusters and until we find a free one. I mean, there's a way of doing that. Just isn't necessarily the best, but there's a way to do that, I guess. Hmm. That I equals 2 that. And as always, you're going to be complaining if no fat I. What I'm not entirely sure about is the fact that it starts at 0. Maybe it doesn't. I don't know. I'm not using stdlib at all. File allocation table cluster map. Alright, 0 is actually reserved, I think. So I can use 0 to say we failed. Cool. Which means if no new cluster, then return false. That part is easy. If we allocated a cluster, then we chain it to say, hey, we just reached the end of file here. We're constantly going to be moving the end of file into new clusters, but whatever. We don't really have anywhere to point it at the beginning, so it's fine. Like when I'm allocating this element, I don't know where this element is yet. This is the next one I'm going to allocate. So for the time being, I'm just going to say this is the end. And then when I actually allocate the next element, oh, by the way, you're not the end. You point to this one. I think that's fine. What I'm not sure about is the number that it returns. Am I okay with just doing that? Just returning I? This next index here, where's that calculated? It's root index. So yeah, it's just a, it should be fine. The problem is testing this is going to be a little bit complicated. First off, no, okay, we're good. Let's just test it. We can test it by just writing a lot into this file until we have a ton of characters, say 512 or more. Well, that didn't work. I can always, of course, just... I think that's actually a problem with the editor. I'm not sure. I would need to debug it. I don't feel like doing that right now. Here's what I can do. I probably need to get to it. Here's what we're going to try to do. we're going to allocate 1024. We're going to mem set it to that 1024, and then we're going to write full file to redo os fat test buffer buff size 1024. So we're just gonna force the file to become bigger without manually modifying it, which, hey, seems almost smart to do. How did I end up on this file exactly? All right. So now by running the demo process, I should be able to do this. Hold up. Where is my demo process? I'm thinking that I probably messed up writing the file entry, and so it messed up the entire directory, which is this directory, which contains this folder, which contains the process that I'm trying to write. So, whoops. Whoops. Either way, I do need to reform the file system. Can always do that. No, you should be there. What the fuck? Where the hell is my process now? Now something else happened here. Because, like, the entire thing is missing? Alright, here's what I'm suspecting. I changed a bunch of functions, including the list directory handler here. This thing. Probably here somewhere I messed up. No, this is not it. The list directory handler. That's not what it's called, is it? The list entries handler. This thing. Yeah, who calls it? That would be this. And I feel like this is not able to to correctly, like, navigate to the correct directory. So something here is failing. Walk result found. Tell me that. No. I can guarantee you it walked to the right directory, but it somehow didn't return the right value. It's supposed to return true. Unless here, 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 or here we failed somehow, but otherwise you should always be returning true. Found true. What's up, dog? Can return empty if there's a problem. Empty if there's a problem. Alright, I can always turn on verbose mode, and that can give me a little bit more clue of what's happening. There, it's reading a bunch of stuff. It finds all that. So it's clearly working to a certain extent. It finds all these.
Zitzak XSW followed your channel.
That's interesting. Hold on. This here is the folder that I'm supposed to be looking into in order to find the applications that go here, the ones that are currently missing. User. Supposed to be there. But I'm not seeing it trying to go into the folder at all. So here. Entering folder user. FS, RedOS, user. You're supposed to find these, but instead you find these? That cannot possibly be. One three eight three E. No, just find and replace. No. How about I just look up user? That's probably better. It's going crazy and taking so long to find anything. My god. Every time I press enter to go to the next search, I just hear my fans like working overtime, trying to find a result, but this thing is so slow. This, kind of. Loads to clusters. Could be because, yeah, it depends on the number of entries in the file. That should be fine. Oh, I have the addresses here. Okay, that's actually super convenient. Because that's kind of what I needed. Because that search was going to drive me crazy. Anyway, it says cluster 2903C000. I think I added an extra 0 there, but whatever. 2903C00. Oh. That was fast. Alright. So that is this directory. That is not folder user. That is the wrong... No. Wait, no, yes, that is correct. Alright, inside of this directory, you're gonna find the folder called user. That's what this means, but it never finds it. So, work directory, what's happening with you? Because it finds entry user, and then list entries handler, this one. Wait, I can use print in here? I didn't even realize. Okay. Found correct entry. See, after user, I expect to see found correct entry, but I don't. Is it case sensitive? It shouldn't be. Because also, none of this code has changed, so it shouldn't be a problem. Found correct entry. That's the one that I want, yes. Alright, so... Walk, where are you? Nope, that's not it. Oh my god, just open this function. There we go. Alright, so you found an entry. Oh. File size is going to be 0 for directories. So when the final entry is a file, that you can't use that to check. Instead, you're supposed to check, I don't know, we can do file size or There we go. They're back. That didn't work. Well, I mean, it worked in the sense that our files are back. That's pretty cool. But in the sense that something crashed. And the worst part is I haven't really seen a stack trace, a proper stack trace, in a long time, so I wonder if that broke. Because this is not a proper stack trace. I don't know what the fuck this is, but it's definitely not a proper stack trace. Wait, I do realize that I'm trying to allocate I should be starting at 2. Well, 3 really, because 2 is like the root directory. So 3 is the correct place to start, kind of. Still crashes. Alright, so can you tell me instead, are you allocating any clusters? I don't think it should be deallocating clusters, because I'm trying to make a small file into a bigger file. Allocate cluster 208085. Okay, which is 32CD5. Oh, I see. Next was always going to be 0 or this value, so it was always going to be pointing to the wrong place. I was kind of breaking the chain there. I think that worked. Bit hard to tell. No, I want to jump to 0x2903800, I think was the file. No, that's not the file. That is the directory, which then contains my file. That is 512 bytes of my file are written here. And then I don't know where the rest were written. There honestly may not be an easier way to handle it than... Wait, don't I have the allocated cluster? Yeah, this thing. So it looks like it wrote them to continuous pages, so to speak. Just don't know where they are. They're not here, which is where you would expect that data to be. Alright, hold on. Alright, no, here. Files being written. Alright, and it allocated clusters. Excuse me? How is this address translating to this thing? Oh, wait, hold on. This whole thing times 512. 512, ideally. Should give me the exact byte that I can go to in order to find the areas where it wrote the file. Oh god, why is it that number? Nine 6C00. There's one. There's hello world, because funnily enough, am I supposed to be doing this? No. That's interesting. Writing to a file kind of just like keeps the current file there. It's weird. I need to improve it a little bit. There's no way to override a file. So the current contents of the file gets shifted over here. This is 256 bytes before that. Then there's an entire cluster here used just for these little bytes here, which are not even part of the file anymore, technically. And if we go all the way back to A000, That is 512, right? Yeah. So it allocated a cluster at 696A00, C00, and then E00 plus the original, but they kinda don't contain 111111, so that's a little weird. I don't think that's not an issue with my driver. I mean, the driver is working fine. I'm able to write files. I'm allocating properly. And again, the tiny issue that I'm having is that I'm not writing back the table to the disk. I also need to be doing that, and I'm not doing that. Which means if I try to read the number, to read the file again, which I technically can't really do because I'm writing 1 to it. But like, let's write B to the file. And then let this fill it in. And this read it. It reads a bunch of B's. But it only reads, let me guess how many this is, 512. No, it read 1024. Oh, because the FAT32 table only gets loaded once, but I'm not reloading it. But if next time I build a system, I don't rebuild the file image, meaning I keep the changes that I made, and I try to read the file, it is now a lot smaller and contains a bunch of garbage. Because I didn't save the FAT32 table, meaning 3/4 of my file are somewhere in the disk, but I didn't write down where. Didn't actually write that part to disk. So I'll need to do that. Alright, the FAT table gets that easy. That easy. Not sure who's calling this. Sectors per fat, number of fats. Oh, that's convenient. Alright. Void fat32fs, write fat with a u32 location, a u32 size, and a u8 count. Why is it a u8? It's a little weird, but whatever. Literally, just change the name from disk read to disk write, and it stays exactly the same. Should be that easy. So, finally, when the new cluster count, this thing where we resize the fat, at the end of resizing the fat, we want to actually commit what we did. Again, just as easy as taking this function, changing read to write. Bada bing, bada boom, it's done. Alright, so manually wipe the file system so we can start over because I already corrupted it. All right, run our demo program, which is going to write a bunch of B's to it. Run this, and we're just going to see a bunch of B's here because it kind of just looks like that. But here we can see 512 bytes of data. We're then going to quit the operating system. We're going to start over. We're going to read, and we're still going to read 512 bytes of data because we wrote the fat allocation table back, which means we're able to read every single file back. Cool. Easy. All right. So that was a lot. That was a lot. That was a ton, and that was too much. So, essentially, to write a file, yeah, the garbage symbols, that's just non-printable. Why is that there? I'm not sure that that's supposed to be there. Should you write the fat table after the allocation too? I am. When I resize is allocation and deallocation. So after both, here I'm modifying the table and here I'm writing it back. So yes, I am doing that. Technically I'm not testing the shrinking a file, but we'll have plenty of times to do that. Right now I don't really feel like doing that. Kind of want to move on to something else for the time being, and we're actually going to be dealing with writing files to this system soon enough, so not a particularly big issue. I fixed the backlight but broke a little bit of the LCD. Oh, so it's not that old of a TV. What was I thinking? Oh no, like a 1960s TV. I wasn't really thinking that. I was thinking like 2000s or 90s. Early 10s. All right. See, you can tell me old TV and say early 2010s. That doesn't count as old to me. It is, but aren't they also flat screen TVs? I was thinking maybe I'm confusing old with vintage. It is technically old, it's just not vintage. Mostly because anything produced after the 2010s is kind of crap. Alright, so I'm not sure if this is supposed to be here or not. It could just be the file terminator. There is a little bit of garbage that's being written. Again, technically because of the way that my file system works, not because of the driver itself, but because of my file system, so I'll have to deal with that a little bit. No big deal. Still though, when you write to a file in FAT32, you need to consider the size of the file in terms of clusters. If you have more clusters than you did before or fewer clusters than you did before, then you need to either allocate new clusters so you can put the data in there, or deallocate clusters so you can free them up so they can be used for something else. Freeing them up, in my case, doesn't even mean wiping them, which means the data might still be there, but it can be overwritten next time, which, by the way, is somewhat common. First off, data recovery, you can even do it after the data has been overwritten. But it's incredibly common to not delete the actual data. When you delete a file, for example, or when you resize a file, you don't delete the data, you just change the index for it. It's that simple. So we should be doing that. That would be cool, but oh well. Defragging is a thing that we're not going to be doing. Fuck that. No, 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 no. Yeah, fixing FAT32 support. Yeah, I'm adding more support for writing. All right. So yeah, that's how you handle writing a file. And then there's the fact that everything that I'm talking about has to do with the file's actual data, so the actual contents of the file. Then there's the actual entry of the file, which contains the file size, for example. Because again, clusters are in multiples of 512 bytes, but the actual size of the file might be 3 bytes. So that's one cluster, 512 bytes, or more, depending on how many clusters the file system uses. But yeah. But really it only takes up 3 bytes. So you also need to sync that, which means you need to write the entry. The actual index of the file needs to be modified to reflect the real size of the file every single time that you change the file. And beautiful thing about that, it's the fact that I wasn't really keeping track of where that entry is in the disk. Now I am. I'm calculating that. I could actually just like do it normally, but I'm kind of calculating it, which is simpler for me in terms of implementation, though it's less optimized. Oh no. It's not even accessing the disk, so it's totally fine. Just technically accessing the same data twice, but from RAM both times, so whatever. So we need to go and modify that entry. In order to modify the 32 bytes of an entry, to modify the 4 bytes that indicate the file size, you need to actually get 512 bytes minimum worth of data, read that,
Kofi Sophie
and
followed your channel.
modify from the one that you read, modify just the entry, and then write the 512 bytes minimum back to the disk. All of those operations you're technically supposed to do periodically in the background and not like I'm doing every single time that you change a file. The reason that I'm doing it like this is that I'm not using it for that much. So it's fine for now to not optimize, but it should be optimized, especially because SD cards. Hello, Coffee Sophie. Cannot be bothered. Let me just put it that way. Cannot be bothered doing that today, for sure. And until I actually need to optimize also. So there's that. Let me not over-engineer this thing. It's not really over-engineering, it's just, I'm just lazy. I'm just lazy, what can I say? There's also, technically, the fact that this file system is the boot partition of the system. So if I ever add system updates, if I ever add other things like those, then it will be useful, but not for saving your normal files day to day. There's an entire different file system for that, which is also not optimized, but it relies on Linux, so it's not as annoying.
You should make the system update forced.
I should, that's true. There was another thing. But, oh, yeah, okay. For modifying the theme of the operating system. So the colors and all that stuff. Right now you can do it from a file. But, like, nah? I feel like modifying a system's theme should be done through the system's UI. Because, like, yeah. But then that means that I need to be able to write that to a file. And I don't have the functionality for that yet, but now I have the file system support for writing files to that partition, so I should be able to do it eventually. All right. I'm gonna do something that I said I was gonna do yesterday, but then I ended up spending so much time working on this driver. There go my headphones. Working so much on this driver that I ended up not doing it. And that is the fact that someone pointed out yesterday. Well, someone asked me about my system's file system structure, like what the actual file system looks like. And I don't really, I mean, I could answer that question, but the truth is it's a mess. No thought went into it. And I kind of want to organize it a little bit. So, chill task, easy to do. So kind of just want to map out what the virtual file system looks like in my system, and also the physical file system looks like in my system, somewhat. And what it should look like, because now's the time to change folders names, change locations, rearrange, and do all these things. Also, the system has a README, which is this whole yap session going on here. Nobody wants that. First off, I really need to have a wiki. And second, like right now I should technically edit this for the instructions on how to run it to tell you that the create fs is not going to be run every time you run the system. Which means, by the way, clean should not remove this. Yeah, this should not be done anymore. And this should not be done anymore. Because now that the file system is read-write, I can't just copy this folder every single time. I should do that and include that in the README, but goddamn, that README is becoming unreadable. So, not really. I mean, it's an average project README. I just find that there's so much yapping for no good reason. Many hours do I work on this per day? Pretty much only when I stream. Occasionally I do stuff off stream, but not. So that's what, say 4-hour streams, 4 days a week, 16 hours a week. It's like a part-time job. Nice. All right. There's an ad coming up on Twitch. We're gonna run that, and then we're gonna come back and kind of organize the project a little bit. Well, not organize, just map out what the file system looks like and what I want it to look like. So I guess we're gonna go more into design than development, thank God. So I need a break. I'll be back in 3 minutes. All right, we're back. And the coffee that I started drinking, Jesus, that I drank at the beginning of the stream 3 hours ago is hitting, and I am feeling hyper as fuck. Also barely had lunch today, so I'm like 90% caffeine at this very second. That's always nice to have. All right. I mentioned I wanna list out the contents of, well, the directory structure of my system. Now here's the thing. In a perfect world, you could just do this. Just go to the root directory and do ls. Maybe even ls recursive. I don't think ls recursive is a thing. Obviously not. But yeah, just go to the root directory, list that, go into each of the folders, list that. That should give you the directory structure. And honestly, there's not that many files. It's not like there's any personal files in here. So we should be fine doing that. Tiny issue. Most modules in the system that provide the structure for the file system don't have that functionality. So that's wonderful, in fact. It's really, really wonderful. Because it's not functionality that we have, we can't really do it. It is functionality that I need to add. So I kind of have the choice of, do I implement this and use that to list out the contents of the directories of my file system, or not? And frankly, it's gonna be a no. It's gonna be a no. We could. I can try a little something, but here is what I can try. I can go to utils, can go to file browser, and can go to main, and it is already set up to give us the contents of the shared folder, which is the one that Linux shares with us. But don't have to. If I make it do this, nothing's gonna happen, but maybe we can make it do something. Bro? What? Oh. Oh. Shit. The disk image is not being reloaded, so... Yeah, this solution is maybe not the best. There. I need this back. I do need this. I'll just have to choose whether I want this or not. Whether I want to recreate the disk image or not. Because like when I'm making changes to the file system, or when I'm making changes to one of these apps, they're being copied over and bundled with this command. But then that also overrides any changes that you've made, so it's a bit of a pain in the ass. But it is what it is. It's what it's. Alright. So for the time being, I'm just gonna recreate the file system every time I run the system, because I'm not actually writing anything to the partition, and I am making changes to these programs, which means I need these changes to be reflected every time I run the system. So this is directory, empty directory, and actually I got an error, no module for path, which is technically not even correct, right? Because I think I'm past the age of diagnosis for schizophrenia. So I think I'm good. The thing about the search path is that I've never actually considered listing the root directory. It sounds really stupid, but I've never actually done it. So, yeah, there's no such thing, no such logic. And what that means is that it tries to find a path that is mounted at the root directory. You can't really mount anything to the root directory. The root directory is just that. It's just the root of the entire file system tree. You mount inside of it, but you don't mount it. So we kind of need to make an exception for that. That if the path matches this, surprisingly, no, that didn't work. Oh wait, it's equal to 0. Well, that's not great. Why does it think that it's listing the root directory just when I'm telling you to list the entire thing? That's string compare probably. Never mind. You good? Alright, I'm gonna go check on him. I'll be back in a second. Okay, here we are. Dog is alive. Don't worry about it. There he is. Hey, Arctic. Oh, he's back. Jester! Are you good? I hope he's okay. Not sure what he's doing. You good? What is happening to you? Hold on. It might be allergies. Alright, I'll be right back again. Okay, we're back. Again, he's right here. I'm gonna keep him out of the room, as I haven't dusted this place in a few days, and I just gave him the allergy meds, but it's gonna take a bit to like actually work. So he's better off getting some fresh air, just not from outside, because that's probably what's causing the allergies in the first place. Anyway, white dogs are very prone to allergies, just FYI. Alright, so, really funny little thing that apparently I can't I don't know what's happening. But string compare for path with this case insensitive doesn't really matter because we're comparing against the symbol, but it doesn't matter. Should be entering here, but it's not. Instead, it's entering here. I think? Yo, Burnout, what's up? What's up? So what exactly are you printing here? Like, what's the result of this thing? Make run is not running? Or is this message coming from somewhere else? No module for path? Ah. Ah. Is my dog pooping? No, he just sits like that. Don't worry about it.
Tima_Gutmensch followed your channel.
I see. So the exception needs to be made here as well. Pretty much anywhere that I access a path like this. Alright, that makes sense. It's been a bit of developing this thing, yes. Alright, so listing root directory. Okay, so actually, root directory for this is incredibly simple. First off, if no out stat, then what the fuck are you doing? Return false. If you're not giving me any data to fill out, then why are you requesting stats for a file where you're not giving me any data to write it? So that would be weird. But then, easy to fill out information for the root directory. The file size is 0, we don't really have that. And the type is an entry directory. Like that. Hey Rudy. Doom working? Technically yes, but I think I need to rebuild it. It's right now it kinda crashes. The entire system actually. Or is it working? No, it crashes. Not the entire system, okay. That was a one-time thing. Yeah, it crashes, but it should work, so I just need to rebuild it most likely, but it should work, yes. Mouse support is not amazing, but from what I heard, mouse support is just not amazing on the shareware version of Doom, so might not be entirely on me. What's the point of leaving him out of the room if he's just gonna be at the door, and the door is slightly open, so I just see this. The entire time I just see this. Hey, what's the point of leaving him out there if that's just how you're gonna act? Alright, anyway. Back to what I'm actually testing. I need to get rid of these logs, by the way. I think it is weird. Either I'm checking that the size is something other than 0, and because this is failing, then I'm not continuing. But I expect this to be hit at some point. It doesn't seem like it is. But anyway, any kprintfs that I have in here, I probably want to get rid of them. Like, what is this? Yeah, this thing, get out of here. File hash. The fuck out of here. We'll truncate this. Found and modified an entry. Good for you. Don't care. That's exactly what he looks like right now, yes. I just see an eye. That's supposed to be a verbose print. These are errors, so these should work. By the way, I really want to make a logger. And I don't know who told YouTube that I'm interested in boot.dev. But recently, I've been getting video recommendations from them. Because for whatever fucking reason, I have notifications turned on. And they're the most ridiculous things. Your logs suck. Here's how to fix them. Like, Jesus, I know, but quiet. Nobody asked. Now, these are not supposed to be verbose. These are errors. But it reminded me that I actually do need to make a better logger than I have right now. One that can handle things like verbosity levels, error printing, all of that stuff. Maybe even some colors, but not in the way that... what is the name of it? ANSI escape sequences? Is that the... escape codes? Not this. I technically have support for something similar to this, just directly using hex colors instead of whatever freaking format this is supposed to be. I want to expand it a little bit, but yeah, some prints like those would be nice. Since you can see there's a little bit of everything when it comes to the logs. You can see logs that are structured like this. Similar structures here, but like not capitalized. Device here, that's not really the correct format. Maybe I should use USB underscore device or something like that. But the way that the formatting that I have right now is something like supposed to be USB error, USB warning, or nothing, just USB. So it's supposed to be USB device, something like that would be better. So I kind of want to standardize my logs a little bit, but you don't need to yell at me, boot.dev, like, don't do that. Also, not in the slightest interested in that kind of content. No boot, well, yeah, no bootloader really. The concept of a bootloader is much more x86 than ARM. Although the Raspberry Pi uses a bootloader, which is also why I'm forced to use FAT32. But... oh my god, Jester, get out. I'll bring you back in a minute when your med's kicking. But this room is kinda... well, actually it's not that dusty, but it's been like a week since I've cleaned it thoroughly. And we're in allergy season, so... compared to my living room that I cleaned literally this morning, I'd rather he hangs out there. Okay, I think I removed all those useless logs. Let's see, for example here. This log is supposed to be a little bit more structured. Then these logs Should be able to do a simple find and replace if I make it case sensitive. At least I can structure the logs a little bit better. But yeah, I want to have a class that helps me, a function that helps me log things in a much cleaner way. All right. Back to what we were doing. The code for the file browser, something a little weird about it. Okay, we enter a file. We enter a directory, right? And we are given the name of it. And actually, we append it to other directories that we've already entered. Otherwise, we just take it from here. Full path, cool. If it contains .red, that is an executable. We should be able to open it by just finding the elf file inside of it and running that, but we're not doing that right now. That's not the case. Stat. Okay, here it is. First we go stat, because if it's a directory, we run this code. Otherwise, we run this code. So if stat is failing, then clearly we got something missing. And yeah, we are returning false here. That's the problem. This returns false, that returns true. So that is the reason why this failed. List in root directory. Okay, we're good. So we don't actually have the functionality to do this, but we're going to implement it. Another thing, for example, in my this logic, I kind of want to standardize it a little bit. I don't know exactly. Like, do I want my file browser to be reusable? Does that even make sense? Forget I said anything. I don't know what I'm talking about. I'm considering things that have nothing to do with what I'm doing. Once I get back to working on my code editor, we'll think about this. But right now I'm taking a little detour and moving away from the code editor, which is mostly moving a cursor around. A lot of logic to move a cursor around, which is... It gets a little bit overwhelming after a while, so I decided to work on this instead. Work on FAT32 file system driver. Easy stuff. And now virtual file system. Alright, so listing a root directory. So in order to do that, we're actually loading, here the module loader has a get module, which uses a linked list, by the way. That's not technically correct. It shouldn't use a linked list. It should use something else, like a hash map. Like, there's a to-do for it here. But that's not the important part right now. The root directory isn't a real directory, like I said. It isn't a module, like the rest are modules. It is a collection of modules, so it should have its own custom logic for handling... Oh my god. Jester, are you gonna stay out there the whole time? The entire point of leaving you out there is so you go get some fresh air in a cleaner area of the house, and now he's... Oh my god. This dog is very obsessive. Anyway, we're going to implement a function for reading a directory, but for the module loader here. So it's going to look like this. List root. We're not going to need a path, because the path is root directory. And you're just going to load that here. The logic for it, I'm a little bit fuzzy on how it's going to work, honestly. Might be due for a refactor how I do directory listing. I'm not sure. For the time being, we're going to return 0. And to do that, we're just going to return list root, passing the buffer, the size, and the offset in here. All right. So this root directory thing, I've barely implemented it. Let me see where I've implemented it so I can take a little bit of inspiration. See, here it's not implemented, here it's not implemented. That's just that, that's just that. The actual file systems do have it. Temp directory has it. Does it really? No. It doesn't. This is one of the real file systems. Network doesn't implement it. Scheduler implements it. This may be the only place in the virtual file system that I've actually implemented directory listing. Before I look at it though, let me check that everything else is literally 0. Yep. All right. So list processes. I'm actually getting like a little bit itchy. Yeah, allergy season is coming, so I need to deep clean this entire desk and that desk behind me. And there's a table here. And also there's like a whole ass piano back there. And a closet over there. Yeah, kind of need to deep clean this room. Since I'm only here to stream, haven't really done it all that often, but yeah, I should probably do it now that it's allergy season. Otherwise, poor guy is gonna have to be replaced by a cardboard cutout of himself. All right, this is list processes, and does it use the offset? It does use the offset. That's interesting. The offset is dynamic. Ah, okay. All right, so the way that the list directory works is you tell me, hey, I want to list the contents of this directory. You give me a path to the directory, and you tell me you're going to fill in this buffer. This is how much memory I have for the buffer. And this is the offset at which you will start. And the offset is actually a pointer. If you look at it, it's a pointer, which means it's read-write. I'm going to do that, and then I'm going to change the pointer, which means if I haven't given you all the data that for listing the directory because you didn't give me enough space in the buffer, then you can just call the same function again, passing the offset, and I will give you the next batch. And I was wondering, like, the offset is just a data offset, right? So how does it handle it? How do I explain it? All right, so for FAT32 or VirtIO 9P, for example, these are actual file systems, which means they have an actual list of contents of a file somewhere in memory that we just read from, you know? So I just give an offset of this is how much data I gave you. Next time, start reading from here. And you start reading from here. So it's a data offset in that case. But in the case of... I lost it. In the case of the proc file system, so /proc, the offset is actually just a process ID. And what it means is, hey, I gave you the information of all processes up to process 13. All right, that's as much as I could fit in the buffer that you gave me. Next time, request information for processes 14 onward, and I will give you that. So it's not necessarily a data offset. That's what I was wondering about. Is it a data offset? And how do virtual file systems that don't really have a big buffer with a list of contents of files, of directories, I mean, how do they use the offset? What's a virtual offset? So it's an offset into the data itself, not into the buffer. So that's kind of how we do it. I guess right now it's kind of convenient because I can just list the contents of the directory one by one, starting on the offset, and fill in the information until I have no more information to fill. And then just tell you where I arrived. Like, okay, I gave you the first 5 modules, so request the 6th one next. I can do that. Since it's using a linked list, it's technically just an array, just fancier in terms of memory management. Well, no, it's not an array in terms of memory management, but it works like one. That's the point. So I can make offset just the index into the modules. Now, as to how much data to write, that is where I want to write a little helper, because the list processes function, this thing. Oh my god. Jester. Alright, give me a second. Alright, I put him in the other room. 30 minutes from now, let's say. I can get him back. Allergy pills should kick in by then. Alright. So the way that this list processes work, which again is pretty much the only place where I've actually implemented listing directories, it's kind of very boilerplatey. We have all this here. It's kind of a pain in the ass, actually. How does it even work? We have a buffer. We have an offset. And then we have a name length. Okay. And a write pointer. Yep. And a count that we write here. Okay. So essentially the way that it works is it is an array of strings, null terminated strings with a counter for how many strings there are at the beginning. So essentially it looks like this. I don't know what else to write. Except these are zeros. Well, there's technically not a null termination here. It's just 32 bits for how many strings there are, and then a bunch of null terminated strings, one right after the other. So that's the structure that it follows. I don't mind using that structure. I just kind of want to make a helper for it because holy shit. I don't want to have to use this logic every single time. And I saw a to-do before in somewhere. Oh, in the temp fs. So this. use something similar to a fuse filler to easily list files. So I actually don't know how this works, but I kind of want to look into it. So the fuse driver, I have a fuse driver actually, so I can look at the code for that. Fuses the file system in user space. Hold on. The file system in user space spells out fuse? Because really, it should spell out fsus. But somehow that spells out fuse. I guess it's file system, so spelled like this, single word, in user space. I feel like I come to this realization every time I talk about it, but yeah. Wait, no, actually, a user space, like that. That's how you get fuse out of this. It's about as hacked together as everything else in Unix. I'm joking, actually. Unix, I may not like the way that Unix is designed, but one thing's for sure, they're not hacked together. Mostly. You can tell some thought went into it, and it was designed well. Just the design doesn't fit the modern computers, in my opinion. Alright. Listing a directory in Fuse module loader. This is actually a replacement for the module loader inside my operating system, but for Fuse. They're not up to date anymore. They're kind of... I developed the one for my operating system, and then I was developing the one for Fuse, and I was like, okay, I'm gonna make improvements to this, and then bring them into the operating system. But I kind of stopped doing that. Now
R30R followed your channel.
Now I'm working on this one and the one inside my operating system, and then I'm gonna bring those improvements into the other one. Or not. I guess we'll see. Wait, what's the main function? Oh, main.c. Okay, that's what I'm looking for. Read directory. Okay, here it is. Alright, so this is what it does, that I found that it was kind of very easy to work with. Fuse uses a filler, and all you have to do is pass it the buffer, the name of the directory, and then a bunch of other information that I don't even know what it is. Actually, I'm not entirely sure. We can look at the structure. The buffer, it's documented. I'm not used to that. I'm used to reverse engineering even my own code. So, all right, the buffer passed to the read dir operation. So this is the one that gets filled in. Then the file name of the directory entry. File attributes can be null. Okay, so you can just get them right away. Interesting. Offset of the next entry or 0. So kind of what I'm doing, just different. Flags, fill flags. Not sure what fill flags are. And returns 1 if the buffer is full or 0 otherwise. Plus mode, all file attributes are valid. The attributes are used by the kernel to pre-fill the I don't give a shit. You can tell. Null, 0, 0. Yep, we're good. But yeah, this is how easy it is to define the contents of a directory.
Lover 111.111 followed your channel.
I love when it reads numbers. This is how easy it is to just create list files in this system. So I want to make something equally easy to use. If I even look at the mail one, read dir, mail sread, here it is, read func. Yeah, the way that I was designing this file system, I don't like, which is why I'm glad that I'm kind of moving away from it. But here, list root directory, it's that easy. You list this, then the number of entries that we have. It's that simple. It's this simple to fill out the buffer information. So I kind of want to have that. I kind of want to create a helper, but to be honest, looking at this code didn't help me in the slightest to figure out how to do it. So we're winging it. All right. I'm going to make a helper for it. So I'm actually going to make it available for applications as well. Even though apps are not able to define their own file system for the time being, they can't do modules for the time being. For the time being the strong word here. Maybe they will in the future, so it's fine. Let me just put it in its own thing. I'm gonna call it dear list.h pragma once, and we're gonna include fs.h. Right? What's even in this file? I see. No, you actually don't need to do that. All right, we're gonna type def a structure. That structure is going to have a u32 count and be followed by, okay, so I need to include types.h. File system dir list, let's call it. Can I do this? Yes, that compiles correctly. Does it have the file structure that I expect it to have? I sure fucking hope so. Right now, the only content that is given when you list a directory is literally just the file names inside of it. You're not even told if something is a directory or not, or size or attributes of any kind. You have to get those yourself, which is fine, honestly. I'm probably gonna keep it that way. What's worse, to work with FAT32 or C++? To have a FAT32 driver in C++. C++ was up to some bullshit today, so I was just like, fuck this language. I literally threatened it with, I think I deleted the code where I did that, so it's not like we're gonna find it, but essentially I had a structure in which I was filling in manually Like you do in C, you can do this. You can do something like this. Like, this is actually not allowed. Oh, now it is. No, it isn't. Oh, because it's missing a bunch of fields. Now I'm a little bit confused as to where the error was last time, because this worked fine. Oh, okay. So my crash out was for nothing. Actually, the issue that I was having was completely stupid. I was downcasting a 64-bit number to a 32-bit number, which is fine because the number was never going to go past 4 billion. But it was giving me the same error that it's giving me here because essentially it's not automatically casting. You have to be explicit about it. Pretty sure if I just do this... This is a uint 8, so it's even more ridiculous to do it, but yeah. Non-constant no, okay. Crash out is back on. Fuck this language. Why am I not allowed to do this? I'm just casting this to this. This to this. Again, it's ridiculous to cast a size to a int 8, but I can cast it to this for that matter. And you're gonna complain either way. Because a non-constant expression cannot be narrowed from type size to 32-bit in initializer list. Literally the only issue is that I'm doing it inside of here. If instead of this, I did this, which is what I ended up doing, all of a sudden there's no problem. In C, this would have never been a problem. And actually, it's one of the best things that I find in C, the kind of declarative nature that you can have with declaring structures. You can do them declaratively with stuff like this. And this godforsaken language doesn't allow it. So we have that on one hand. And on the other hand, we have the fact that a file name is divided into 3 non-continuous sections of 13 characters total. And if there's more than that, the next part of the file name will be found before the current one. Not after, before. So you read the file left to right, and then right to left, and then left to right, and then right to left, and then left to right, and then... So it's really a lot of competition today. We got some very strong contenders for stupidest system. The thing is, FAT32, once you've dealt with it once, you're done. C++, though, it's a language. You have to deal with it constantly. And yeah, I feel like C++ is overall worse to work with because you're never done with its bullshit. FAT32, I'm pretty much done with its bullshit until I optimize. And that's my bullshit that I'm dealing with, not its bullshit. So, yeah. Alright, real quick though. I made all of these changes to FAT32 that I kinda need to commit before I start working on something completely new, and I forgot to do it. Though I've already written not a whole lot of code, but some code. We're good though. FAT32. No, actually, we have been tagging them F32. There's one more thing I need to do in FAT32, actually. Hold on. There's one tiny thing that's missing. Wait, can I just yeah, I can just do this. It's easier. Easy. That was missing. Okay. Update file size. Alloc. Alloc. Bats. Alright. Had to do that real quick. Moving on to... Oh, wait. Okay. I just realized why yesterday I pushed a change and I removed some code that left a unused variable, and that's an error because I have a W error turned on. And usually when that happens and I push an update that breaks the system, I get an email from GitHub, but that's only on the main branch. Right now I'm on branch 6.7. So that's why I didn't get an email for it. I didn't realize until this morning. Alright, back to this thing. Again, the logic for a directory list, it's going to look like this. We're going to have the number of entries that there are, followed by null terminated strings, one right after the other, containing the contents. And you're technically not supposed to access it like this. Like, what even is the size of this thing, by the way? The short story for why I don't use AI at all is I don't need it. Nor do I think that it has any utility. Like, what is the size of this thing? 8. That's not right. Yeah, so. Frankly, null terminated strings are some of the worst things that C could have ever done. And it's funny seeing how every other language has improved on them. And you could easily improve them in C++, in C as well, but I don't think they have. To be fair, I use C99, so maybe newer versions even have defer, as far as I know. You don't need to make your own programming language to have defer anymore, like I did. But shit. I don't think they have explicit sized strings. You can easily implement them, and for example, I have, but they haven't. Alright, so you're trying to fill in a... this is supposed to be a pointer, by the way. You're trying to fill in a directory, and you do that by just putting the name in here. Easy. For that matter, let's make it a little bit more complicated by returning a boolean. And here, putting in a limit. And then also this must be a size t. Alright, creating a function to help me create this thing, which is really just going to return, okay, look how easy it is. to do this. How much of a breeze it is to initialize stuff in C. I only need one variable, so I only fill in what variable. C++ would complain that I'm not initializing this and this. Fuck you want from me? All right. Or no helper limit, we're just going to return false. And can I vibe code while watching a real coder? It is not recommended, no. But you can. It is not an approved method. All right, so to fill in a directory, it's pretty simple. We first check if the helper's offset plus the length of the string, which we can calculate real quick. Just once. If that's bigger or equal than the limit, than the helper limit, then we just return false. Otherwise, we have enough space to write into our file, to our list. So we're gonna mem copy the name of the directory, right? So let's just start with that name, with the length that it gives me, +1 actually, because +1 is going to also copy the null terminator at the end. That's gonna make it convenient. Where are we gonna do that? Into the helper list, no, the helper list plus the size of an fs dir list, which is really just the count of it. Plus the helper offset. All that cast to a void pointer. And we need to include memory.h. All right, so we're going to do that. We're then going to change the helper's offset by adding len +1 to it. We need to leave space for the null terminator as well. Pretty much everywhere we're using +1, so let's just do that. And finally, the helper list count ++. Okay. So what it's going to do is we're going to have a U32 count followed by null terminated strings. So it is going to start at here, the end of the structure. It's going to write the string, including the null terminator at the end, and then keep track of where it finished writing. Next time it's going to do the same thing, as long as it has space to do it. If it doesn't, it's going to return false, and whoever is using this helper is going to be like, okay, I wasn't able to write this one, so this one failed. We'll handle that. All right, so what you're going to do to list the root directory is you're going to include this new file, which is files dir list. All right, you're going to create a directory list helper, and you're going to create that with create dir list helper using the buffer and the size that we were given. So that's going to know how much to fill in and where to fill in. Whereas we handle our offset personally, but right now we don't really have the offset. Linked list get returns what? Returns a void pointer, which I think I had this issue recently. It doesn't return the data itself, it returns a node. And that's exactly what we want. Even though we shouldn't be using a linked list here, since we are, we might as well take advantage of that. I don't know what a U63 is, but... Alright. Alright, so we're gonna get each module in our list and if the module exists and has data, then we are going to cast that data to a system module. And we are going to dir list fill helper with the name coming from mod mount. And if that fails, then if there's an offset, we're going to fill in the offset with the current index, meaning we weren't able to write this entry into the buffer that you gave me. So this is where we left off. If you want more, send me another buffer. Start listing here. Cool. Otherwise, we increase the index by 1, but we're not going to use it again. What we're going to do is we're going to simply move on to the node next, like that, while node. Okay. So, while there's an ad on Twitch, we're using this helper to fill in our buffer. We're starting with an index, which will start at 0 if we're not given an offset, or if the offset is 0. So we'll get the first element of the list. We're going to do it like this. then if it has data, we're gonna read that data, try to fill in our buffer. If we can't because there's not enough space, then we just keep track of where we left off. And forgot. Part of this is we return the helper offset, which is how much data we actually wrote. We have to return that. All right, so if we can't write any more data, then we're just going to leave it here. We're going to write down where we left off, the last index that we weren't able to write. So next time, let's say that you wrote 4, so index 5. Next time, start at index 5. And we'll get 5 and start from that one. And return how much we actually wrote. Otherwise, we increase the index because we use it to, calculate the index. And we move on to the next node. So long as there are nodes, once we run out, then we're done. And we say how much we wrote. All right, so that should fill in the names of modules with a tiny little issue. They all have a slash at the beginning. But it is there. It is there. All right, so now we have the actual file system structure here. I'm pretty sure it's not gonna work. No module for path slash proc. So why did we end up with 3 of them? I have no idea. Why 3? I was expecting 2, this one and this one, but there's a third slash here being added for... Oh. I understand why, actually. It's a bug inside the actual file system viewer. But what isn't a bug inside of the file system viewer is the fact that all of these are mounted to slash proc. That's actually not wrong. They're mounted to slash proc. Because, like I said, there really wasn't a root directory until recently. So that's a bit of an issue. But now that I have this little helper, we turned this messy code. It's not that long.
eCactus2 followed your channel.
31 lines of code as opposed to 19 lines of code. So it is fewer, but most importantly, it's so much easier to read because we have this helper, index, we start here, we go through them. That simple. So that's cool, convenient, helpful even. Now, I have a decision to make. How do I move on? I think the correct thing to do is every mount point that looks like this. Hold on, why can't I search? Every mount point that looks like this is going to have to become that. Right? Or... Wait. Yes, I think so. The slash is implicit. Because what if I want to make the modules kind of recursive in a way? Like you can mount a module inside of another module. Yeah, I'll just keep the slash kind of implicit like that. I'm pretty sure everything's gonna break. Yeah. You know everything is broken when this is this color, because I have a theme and it didn't load the theme. Now, do we have any errors? Module, failed to load the module theme. Init failed. Init failed? I wasn't expecting the initializer to fail. But okay, the initializer for the theme module failed. So we can look at that one as an example. Its initializer is this one, load theme. Oh, because it tries to access slash shared slash theme. Or it tries to it tries to access slash boot. It's not able to access either of those, so it clearly fails. All right. Here's what I can do. Which is kind of what I was doing in the fuse file system. That is, skip the initial thing here. Now, this check becomes something different. If there's nothing past that point, then, okay, we're done. It's a root directory. Simple read, simple write, okay. This uses file descriptors, so we don't have that issue. This also uses file descriptors, so we don't have that issue. Here we go. Where's the path used? I see, this calls open file global. And there we go. Not found. Wait. Yeah. You're not supposed to open the root directory. It's just a directory, you list it, but you don't open it. Which you don't need to open it to list it. Doug, he's here. No, I sent him away for a bit because the room is a little bit dusty and he was having allergies. I gave him an allergy pill, but he's... I'm waiting for it to take hold. Actually, I'm gonna go get him. Because I was supposed to do that during the ad break, but I kept working, so I'll be right back. Alright, he's back. There he is. Hopefully no longer bothered by allergies. Now it's just me. Alright, so this should correctly... Brother! You were doing fine until you walked into this... What the fuck is wrong with this room? Like, again, it is a little bit dusty, but it's not like it hasn't been cleaned in a year. It's been like a week. Tops. Yeah, that's about a week, I think. Um, no, that. Yes, yes, yes. Won't initialize the file system if this is not correct. So anywhere that I'm doing this get module thing, see /proc here, is now just proc. Wait, you don't even need that. Just search for proc. Alright, hold on. Stem dog. He was doing fine until I brought him in here. He was doing fine until I brought him in here. So that's great. Anyway, proc. Here we're doing that, here we're doing that, here we're doing that. Here we are not, so we need to do this. And yep. Okay. So we hopefully will have our file system back. Yes, looks like we do. Looks like we do. Alright, everything looks like it's here. And now, okay, this is now correct. /proc. No, no, it's not. No, it's not. It's /proc. But that is a bug inside of the actual file browser here. The bug comes from the full path. It's probably an easier way to write that, but whatever. Because the directory's name is /, and we're adding a / here, it was doubling. So that's a problem with the file browser, not so much with the file system itself. Though it says no module for path proc. I wasn't expecting that. Because, like, you're clearly able to access... I don't know what you're talking about. Alright, we're gonna have to fix this. I guess it's not fully done. So the one that's printing that is actually this one, get stat. So let's put some extra prints in here. Print the full path. Start with that. Ah, well, hold on. It's just that the order of things is wrong. We were looking for the path before we advanced it, so it was actually looking for /proc, not proc. But the print had it right, but the actual logic didn't. I swear I saw something move on the left side of the screen here, but that doesn't make any sense. Anyway, it should have worked, but it didn't. Oh, okay, I understand why. So if I want to implement the entire file system being accessible, I have to implement stat and list directory, because otherwise fail to get info for /proc. So that fails, because we don't actually have that information. All right. I guess this is a little chill thing to work on for a bit. Yeah, okay. It doesn't have any references to stat, that's the problem. Stat proc stat. All right, where's the open file function? This is it. Okay. Oh God. It's kind of a mess. I should call it stat proc because everything else follows that logic of something proc. So stat proc. And stat proc does not have that signature, I can tell you that much. What signature does it have? I think it's a boolean that it returns. Returns a boolean with a const char path and an fs stat. So I need to implement that. All right. This logic isn't amazing necessarily. So maybe I'll just redo it. All right. Give me the length of the path, and if there is no length, then I'm assuming you're trying to stat the root directory. In that case, the root directory of this module, in which case the size is 0, and the type is entry directory. It's actually the same as it is for the root directory, so it's that simple. Otherwise, the path that you gave me is actually a file system, a process ID. So I do this logic. And what this logic does is it parses the ID, as well as advancing the path to the next part. There's also some IRQ stuff here, which to at the very beginning and here, and you return false if there is no process. Otherwise, we actually do the same check again. So maybe, well, let's make this check happen manually like that. We do the same check once we've, so our directory looked like this. Well, first off, it can look like this, in which case it's not handled by us. It can look like this, in which case it's going to be handled by this thing. It can look like this, in which case it's going to be handled by a very similar function. So let me also create a helper for that function, because it's starting to get to the point that I need one. Nope. Where is this fs stat declared? It's in system module. For the sake of simplicity of being able to put this all in one line, I'm going to make this function return a boolean, but it really shouldn't. Or it doesn't need to, really. It's literally just so I can put everything on one line. Because, like, once you call this, you don't really need to do it again. Alright, so our directory now looks like this. If no strlen path, then same exact logic as before, stat dir. There's no special information for what's inside the directory. We just say it's a directory, and we don't know the size of it because we're not calculating that. Otherwise, hold on. Either way here, I do need to IRQ restore. This is where the fur would be incredibly helpful. But alright, that's it. Those are the two directories that we can possibly have. Anything besides this point is going to be an entry file. And if it's /out, then we're trying to read the process's standard output. And standard being a strong word there. Its size is actually held by the process itself, output size. So we just write that. And otherwise, state, the size is the size of the proc state, which is 4 bytes, I believe. Those are the only two files that a directory can, /proc can possibly have. So it's really that easy. And then I also created the stat proc out stat return like that. Implicit declaration. Wait, this whole time I actually haven't been including the file that I... There. Cool. Did that work? No, because I also am not importing. Files, dir list. Oh my god, what now? What do you mean it was not declared? It's declared right here. Stat dir. Inside the file. Fucking C++, brother. I hate this god-forsaken language. And by god-forsaken, I mean I have to do this shit every time I want to use it. That's not the definition of god-forsaken. I don't know what is. Forsaken by God, literally. Or at least I wish it was. Statproc was not... Oh, well, I'm also using the wrong name, so that's not helping. But hey, fuck this language anyway. Alright. So now we can go into proc. And it actually, I forgot that it did this. It lists out processes not by their ID, but by their name. Forgot that it did that. Can I go into it? No. Failed to get info. Well, fucking obviously, because I'm listing the processes by name, not by ID. That's a problem. It was clever until it wasn't. I'm listing the directory. It was cute until it wasn't. But I guess we're here to fix that, right? So, all right. Stat dir list processes. Here it is. All right. So we're gonna do a couple things to this function. First off, we're gonna do it like I did the other one, which is much more elegant. And second, I'm actually gonna split it into two. I'm going to create a new directory for /names. Maybe not. Maybe it would be cute but useless. To essentially list out the directories with their names doesn't really provide me any useful information. And the only reason that I was doing it like that is because it doesn't really like use this for anything. But now that I actually am using this for anything, this doesn't really make sense. See, this to do, I would have never been able to do it. Because you can't go to /proc /kernel/out. You have to go to /proc /0/out. Or /1. I think /1, because /0, process ID 0 is just invalid. Alright. Module loader. Get me that. And let's start refactoring this whole thing. Alright, so instead of a right pointer, get rid of that. Buffer and size, that easy. You don't need to keep track of the count either. You have a process list. If there's an offset, you're just going to go through the processes.
The Schizor 7 followed your channel.
I'm not entirely sure that this is correct, this while.
Jack 2X code followed your channel.
Wait, hold on. I already know if it's correct or not. While proc and proc ID is not offset. Oh no, it doesn't matter. It doesn't matter. Okay. So essentially, we just skip until we reach the correct offset. And again, the offset can be anything. It doesn't have to be a memory address or anything like that. So it's particularly convenient. It's literally just the ID of a process. So I read up to process 7. Next up, I try to read process 8. Yep. And it reads the next one. No. No. You don't do that. Don't think you do that anyway. And then, while proc... If there's a process that isn't like that, okay, so instead of using the name length, we're actually going to, what is it, a U16, the process ID, is a U16. So that's a maximum of how many characters? 65,565, something like that. The number is something like that. It's 5 characters. All right, so let's put it at 6. And then just string format buffer into name, cap at 6. The format is this and proc ID. And then we're going to call fs dir list, oh no, just dir list fill with the helper, and the name is name. And then we move on to the next process. And if we fail at doing this, because we don't have enough space in the buffer, then if offset, then no, if offset, then offset, the value of offset is going to be the process ID that failed, which is why we place ourselves at the process that the offset gives us. That's correct. And then that should be it. Return the helper's offset to tell us how much we wrote. We don't need to do this anymore. Whatever the hell that was, we don't need anymore. And helper per offset. There. So that should allow us to list the IDs of the processes. 1, 2, 3, 4. 1, 2, 3, 5. Actually, there's only 5 processes. Yep. All right, networking is completely disabled, so that disables like 50 different processes that initializes. So we only have 5. Cool, but this is for listing the entire like directory. Right, on top of that, we're going to want a proc read dir function. That is the one that's actually going to get called. And And similar to stat, oh god. It's gonna have some logic similar to this one. I just realized this logic is so wrong. But it's also so unnecessary. Because if we're in here, IRQs are always disabled. So this is completely unnecessary. But it is going to be useful. Hold on. It is going to be useful to replace IRQ restore with like atomic operations for like multi-threading eventually. So I'll keep it. So it gets uglier. So much uglier. Now I have to do this. Here. Here. And good thing I checked, because that would have made a mistake. That would have been a mistake. Alright, back to this. Alright, for trying to read the root directory, then we are going to do so with list processes. Don't care about the path, actually. We should be using the path for anything in this function, so we can get rid of it. Yep. The buffer, the size, and the offset. And we also need the IRQ flags.
Bist OG followed your channel.
IRQ save disable. Alright. So that's going to list the root directory. Otherwise, the files that we want to list for a process are always going to be the same. So maybe I can just copy this logic real quick, but without the while. Eventually it might get more complicated than this, so not necessarily a problem to do this. List proc files. Alright. I have to respect this offset stuff, but it's very unlikely that you'll run into this issue, but maybe. If index equal to 0, this is painful to write, but whatever. If no dear list fill helper out. That's backwards. Return that. Well, helper offset. This is so dumb. Okay, I'm just gonna hard code it real quick. Can I do that? Yeah, I should be able to do that. Okay, that's convenient. Why is it indexing like indenting like this? That's so weird. All right, there we go. That's a kind of ridiculous amount of boilerplate, but I think I should now be able to list out the contents of the directory of /proc and out and It's supposed to be state, so I'm not sure what happened there. Why is it just I don't think that's what's happening, but it would be really funny, but no, I didn't mean to do that. Proc1 Who told you That's not a real valid file. Why is this happening? State. Why is it That's so weird. Because it is writing it correctly. So that's baffling. It can fail if there's no helper, no list, or no limit. Or it can fail here, but it's not failing. It's not failing at all. So it is copying, and it's copying based on the length of the name of the file. Which I do believe that you're reading correctly. I mean, here it's working. So, could be a rendering issue, that's true. Okay, where is it? File browser, here you are. Where's the actual like rendering of it? Draw string, here it is. Just print that. It's gonna print everything, but... Oh, that's weirder than I expected it to be. Hold on. Proc 1, 2, 3, 5. I open it. Out, state, out, twice. Twice. What? That's weird as hell. Alright, tell me. Wrote I files. Alright, so the helper should have the list, which should have the count. Change state to something else, probably. Wouldn't be correct, but yeah. Wrote 2 files. Interesting. The funniest part is this also happening? See, these work perfectly fine. These are actual file systems too. So I don't think the problem is... I was thinking like the way that syscalls work kind of changed a little bit. There's now memory copying, which I don't want. Kind of want to go back to just like validating memory but without copying. But I thought maybe it would be that, but no, like these are way longer and they work fine. Alright, so we're writing the correct name, I would say. Maybe not. Hold on, it's worth checking. Yeah. Very much hacked together, but hey, that should work. Yeah. And this whole thing needs to be initialized and cast to a char pointer. Cons. All. Console becomes cons. Everything else is fine except for the last one. Applications, that's correct. If I open one of these, it's actually gonna run it, so that's not what I want. Let me go into one of these. Game of Life, for example. Cache. That looks correct to me. Oh, you can actually go outside of the root directory. I didn't realize that. So it's not even this that's failing. It's either a rendering issue. It's not a rendering issue. So now we're printing the name like 50 different times, but whatever. Found entry cons. So we're receiving it wrong. Because it's actually console. And again, 3 characters missing. Same as state. State becomes st. and console becomes cons. All and 8 is missing. Alright, so on entry is being called into traverse directory. Traverse directory, the function directory file. File comes from the reader. Really weird shit. Alright. To debug this, here we are. We're just gonna dump the data. You're obviously gonna complain about this bullshit. Is there any reason to use AI? It worries me that nobody asked themselves this question, to be completely honest with you. No, yeah, as a char is fine. Buffer I. That should print that. That's an interesting thing. I'm providing a buffer of 4 kilobytes, so there's definitely enough space to write 2 files, out and state. Grand total of 8 characters, pretty sure they can fit in 8 kilobytes. So that's not the problem. I am seeing an offset here that I'm kind of not expecting. Oh no, wait, okay, because these are 4 bytes for the number of entries. So yeah, 4 bytes. Then the first one starts here. And that is... No, actually, what the fuck is this data? Hold on. Can you print it as a printable character as well, please? Oh. Oh wait, list directory contents doesn't go through for this file, so we're gonna see it here, okay. 1, 2, 3, 5. That is correct. It's exactly how expected. 1 character for 1, 1 character for 2, 1 character for 3, 1 character for 5. Alright, so we go in here. Yeah, it's not writing enough characters though. Two entries, 0, 0, 0, OUT, there, ST, nothing else after that. And it reports back that it wrote 10 characters, which is 3, 2, 1, that's 6, 7, 8, 9, 10. Well, characters, 10 bytes, which it did. But then I'm pretty sure we very much gonna hard code this, but whatever. Pretty sure if we do this, we're gonna read the correct data. Constant n with expression of type bool is always... The fuck are you talking about? Oh, okay. Literally gonna hard code this part. Never mind. Never mind. Hey, goldfish. Building my own kernel. Risk fee. Nice. Risk fee is interesting for sure. I definitely want to check it out someday, but not today. But never, never, never when I say. All right. Wait. Motherfucker. No, return false. Okay, no, that's good. So you're saying that you wrote... Oh my god. Okay. You don't return the helper offset. You return... the dir buff size of the helper. And what is the dir buff size of the helper? There's an add starting in a minute, so we're going to implement it by done. It's the helper's offset plus the size of the helper's list. Of an FS dir list. That's why it was missing 4 characters, because it's missing this. That's what it uses. Alright, so you have to do that here as well. And here as well. And now this to-do is actually done. The to-do is to done. And finally, here and here as well. Alright, here we go. Console. Proc 1 out state. Boom. Alright, there we have it. Okay, like I said, there's an ad break, so I'll be back in 3 minutes. Okay, 13 seconds left of ads. But um hmm. Alright, didn't miss much on those 13 seconds. Alright, so finally I was able to implement the process files properly, anyway. And frankly, the issue that I was having with 3 characters being truncated at the end, I should have realized that's 4 bytes less being written, which is the exact size of the number of files. So I should have realized what was happening a lot sooner, but whatever. We all make mistakes. Yeah, I have been streaming for like 5 hours, so happens. Alright, we're gonna get rid of all these logs. Like this one, that one. That stays. This log stays actually, because it's an error. This one stays. And alright, oh, and Jester's back, so we get rid of that too. Though he's eating right now, so it's back. Alright, so we have root directory. These are all the modules that are in my system right now, which is actually what I wanted to do. I wasn't supposed to code, by the way. I was just supposed to manually go through my code and find these modules. But then I was like, listing the contents of the disk probably seems like a good idea, so let's do that. And we can go into /proc. We can see all the running processes. There's now actually a few more than there were before. Alright. And inside of them, we can see that we can see their output or their state. We can't actually access this content yet. The file browser doesn't have that functionality yet. We can go into temp, but I don't know if it's going to work. Nope. We can go into theme. It's not going to work. Theme is actually not a folder. So that alone isn't going to help. We can go into shared, and that's actually what I built the file browser for, so here we can very much see the different folders. Did I write that? Oh, wait. This can read text files. It can display text files. I'm learning this for the first time, by the way, despite me writing this code on stream. So, anyway, here we can see actually the code for my text editor, code for Game of Life, and code for my game. I actually moved it in here. It actually displays the code. Well, it should open it in the text editor, but it doesn't right now. I don't have that functionality yet. I don't plan on having that functionality anytime soon. Should be able to also navigate inside of boot, but we're not because we don't have stat. So we need to implement that. That would be nice to have, because boot does actually... Wait, why don't we have stat? I implemented it. So it should be there. But whatever, we'll look into why that's happening. Besides that, we have audio that's definitely doesn't have stat, so it won't work. Doesn't have... Same for in. Disk, also, graph, random, console. Alright. And temp also. Temp is weird because I thought temp would have that, but okay. So the boot directory goes through file system. It actually is implemented right here. When you call its stat function, which you do call it, it calls fat32 stat. It all leads back to debugging the FAT32 driver. It's this check here. There's no file size for directories. Nope, that's the wrong one. Boot. Still can't go in. Alright, so we bring this back. Couldn't find blank. Brother. That's actually so funny. No, it's not. It's kind of weird. Bye, goldfish. Thank you. I just hadn't considered the possibility that, of course, if path and if strlen path, we need to handle the root directory separately. Return dir stat dir. Right. So the root directory actually gets filled in like that. Using files dir list. The root directory is a special case because it actually doesn't have a file system entry. We're just told by the disks, well, the partition's header itself, this is where the root directory is, but we're not told any information on it. It's empty though. That's a problem. What is supposed to happen? But at least that worked. Entering folder, but then it doesn't actually enter the folder or do anything with it. List contents. It's kind of the same issue that the other one has. We don't have a root directory entry, so we don't have video quality 480. That should be there. You should have it. I love how absolutely useless Twitch is. Alright, so same thing is happening here. If we're trying to list the contents of the root directory, which so far we actually haven't done, well, the root directory of the boot file system, we don't really have a file system entry, which is then used to access its file cluster and list directory. So kind of this whole thing. I mean, kind of. There, that should fix it. Because I was already taking care of this, but it probably wouldn't have worked anyway. Alright, there we go. Though that's not all the files. So is this the first time that I run into a kind of overflow?
Cell64DD followed your channel.
I'll need to refactor this code as well, but I kind of just want to know, is there too much is there too much information and it cannot fit, or what exactly is happening? So wait, read there can probably tell me. Not that one, 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 not that one. This one. And bring back this log real quick. I know I'm requesting 4 kilobytes worth of data. I'm receiving a lot less than that. I'm receiving slightly above 512 kilobytes. Am I not doing this correctly? What's the total count? I see. Hash offset, offset found, cursor, cursor length +1. What is going on here? What in the indentation is going on here? There we go. Right pointer plus lang is smaller than the buffer plus the size, then write that. Otherwise... Alright, I don't feel like debugging this right now. Let's say FAT32 listing directory not yet working. And instead implement temp, for example. This one has temp list. And if I'm not mistaken, it has... Am I even using this for anything, actually? STD, okay, yeah. I completely made that up. But hey, at least I made this thing. Okay, no, this doesn't make any sense. There's no stat function here at all. Yeah, that's the problem. Alright, so we're gonna implement that, but the entire way that the entire way that temp works was just for a simple test, so it's kind of dumb. TMP stat arch 64 arm. All right, boolean TMP stat takes a const char path and a fs stat out stat. All right, so if no strlen path, wait, no, we need to do path equal to seek2 path this, which just advances it to the next one of these. If there isn't one, then we return a dir stat dir. Otherwise, we're going to create a file system dir list helper help files dir list create dir list. No, that was right. Create dir list. Oh wait, no, there's no need for that. Otherwise, we can assume string compare std path equal to 0, then out stat oh, when did I do this entries thing? Oh, okay, that's convenient. All right, so I forgot that I was doing this. This is something that I took from the Fuse driver that I was writing. You can essentially just make virtual files with just one line and then access them like this. It's particularly helpful. So, you just call eval entry with the path that you were given, and if file, then out stat size equals to file buffer size, and out stat type equals to file type, and you return true, otherwise you return false. So it's really that easy. And then to list the directory, it's going to be also particularly easy. You have to create the directory helper. I feel like autocomplete has been particularly stupid today. Is that it? Max entries? Yeah. Did I really call it max entries? It's just a dumb name. Max temp entries I++. Entries I. That is the name of our file. If not dir list fill helper with a name then if offset equals to I, return dir buff size helper. For drivers, usually there's specs that you can follow. Depends. There's a reason I haven't bothered with PCIe in a long time, because there's no fucking spec. Besides that, yeah, usually that, but not so much docs for this, since it's all custom made. Should document my code a little bit better, but it's mostly self-documenting. It's mostly like stuff like, okay, did I call it dir list helper create or create dir list helper, something like that. But besides that, the code itself is pretty self-documenting. All right, so this should list out this directory as well. Also, hello, Ice Dave. We're making a proper file system. We're gonna be a proper country. If only I remember where I'm trying to look. Oh, temp. It works. In the sense that it crashes. Cool. Why? I, again, have not seen a stack trace when there's a fatal error in a million years. And I don't know if a pull request changed that or if something else broke. But something's definitely broken. Is it you, Judas? Assuming it's you. Yeah. Helper, entries, name, data. So probably... What, it doesn't have a name? Oh, yeah. Why am I going to the max? Should be going to the entry count. That's the problem. Just casually accessing uninitialized memory. You know how it is. And there we have it. STD, which currently doesn't contain anything. But this process right here, the entire reason I created that file is for this process. So if I make it right to that file, and then I go here, and I go here, it's empty. Yeah, we tried. That should work someday, but it doesn't right now. Anyway, we can list entries inside of this directory. Is there any other obvious directory that I want to be able to list contents into? Proc already works. TMP already works. Theme is not a directory, but we need to stat. Audio, I haven't touched this one, so no. In, I haven't touched this one. Disk, I haven't touched this one. Graph, I haven't touched this one. Random would be nice, but we currently... I'm actually surprised to see it here. When did I even create it? Who's driving that? RNG module. When are you from? 8 months ago. Okay, so... I'm surprised that it works. Actually. Well, we can actually implement this one real quick. It's really just a matter of going RNG stat. We can even like speed run it. Char path fs stat out stat. If no out stat, return false. Otherwise, stat size is 0 and out stat type is entry file, and we return true. That's literally it. Also, I wonder how long it would take me to implement this. It's just strings. Damn it. I was wondering how long it would take me to implement whether something is a directory or a file. Kinda like Linux does it. Ubuntu anyway. You can tell that this is they're all folders except for the white one, which is a file, and this one, which is a symlink. So that would be nice to have, but right now the list that I'm using to draw this is literally just the strings themselves, nothing else. So I'm good. Don't need anything else right now. I do think, though, if I try to open random, will it actually give me random data? Not quite. But I'm not sure what's happening behind the scenes. I just can't see anything here. Alright, and last one I'm going to do this for is theme, and then I'm going to end string because it's been... Oh, hold on. Console and theme, because those are going to be useful. Especially the console, because you'll be able to access the console from within the system. That's pretty nice. Here it is. Get stat, console stat. Can I just copy what I did in random, please? Since it's something very, very similar. Console stat, where it's a file and the size of it is... It uses a ring buffer. Forgot you did that. Holy shit, this is complicated code. This is definitely due for a refactor. But hey, for the time being, that's all I need. And it can use my virtual file thingy that I introduced, so that would be nice to have. But anyway, this should allow us to maybe open the console, I wonder. If not, worth fixing tomorrow. Boom. We can read the console. Although we can't scroll. And there's actually something like 64 kilobytes buffer, if I'm not mistaken, so... Oh, no, it's 12 kilobytes. Still, plenty of data. Feels like this is not 12 kilobytes, so we can't scroll and we can't see the bottom of it yet. But again, tomorrow maybe I'm gonna make that little viewer scroll because it would be nice to have. Maybe I want to give a little bit of love to the file browser tomorrow. But okay, last one I want to do then is theme. Which again just requires me to add a, not that. Requires me to add a stat function. But the size of the theme is a little bit weird. It's... See, when you read the theme, this is what it gives you. That, and it's a file. It's a data file. You don't really get to read... Yeah. Failed to get info for theme. Oh, I haven't actually plugged in the function. It's going to be a data file, not really readable, so it probably won't look like anything. Failed to open file. Well, that definitely surprised me. Oh, there's no file open. There's only simple write and simple read. There's no... That's another thing that I kind of need to consider. Like, didn't exactly do it the best way possible. You can open a file, which gives you a file descriptor, and then you can use that to read and write to the file. Or you can do a simple read or a simple write, backwards, which is a kind of atomic operation, so to speak. And it all happens at once without needing to open the file or anything like that. The problem is that they're two completely different things. So here I have implemented open, simple read, simple write, but I haven't implemented normal read, normal write, so you can't actually access it like that. I'm gonna add a to-do for it. We're going to want to merge those as much as possible so I don't have to deal with this shit. It shouldn't even be too difficult. I think... Yeah, it shouldn't be difficult. Alright. So that's it, I think, for the ones that I wanted to implement stat for. We can actually access this directory, technically this directory, but it's a bit weird. This one needs a little bit of work, it looks like. We can access it partially, but wait, is there just a limit? Is there a hard limit implemented in the file browser itself? There literally is. I was thinking it was a driver issue. No, it's literally just display issue. No big deal. I'll have to implement a stack kind of thing. Maybe I'll do that tomorrow. A stack structure. Wow. A stack structure to handle these types of things. But also be able to grow infinitely. But that's for tomorrow. So again, just to go through the list one more time, because I kind of got interrupted there. We can enter this directory, this one, but we can't read anything. This one, apparently. Not this one yet, I haven't implemented it. Not this one, haven't implemented those. This, but you can only read data, so actually it might be the same issue as with theme, that you can simple read, simple write, but you can't actually like normal read, normal write. So that may be the issue. And finally, probably the most useful one is console. We can read the console directly from here, even though we also already had that. All right, making a noise. Yes. So that kind of answers what my directory structure was, which I was wondering since yesterday. Somebody asked me, and I was like, They asked me like, what is your directory structure? And I'm like, that is a good question. I wish I had an answer, but I'm not sure. Now I can actually map it out, which is better than doing it manually, which is what I was gonna do. And of course, we can also maybe improve it a little bit. So maybe tomorrow I want to focus a little bit on this, on the file browser itself, on improving the overall structure, making it make a little bit more sense, on implementing some of the new features that I've added to the file system, and on unifying simple read, simple write, and normal read, normal write. Because, yeah, you need to be able to read or write files any way you want. Alright, that's it for today, though. It's been a long stream, actually. So, got a lot of FAT32 stuff done. I can actually write to that partition now. And I got... I can also continue refactoring that, but like some other time. But yeah. Alright. LinkedIn. People use that. I technically have one. Every once in a while they send me a message saying that it's still in hibernation, just in case you didn't know. No, I fully know. I don't want to use your damn social network. Thank you very much. It's horrifying. It's horrifying there. It's like Twitter, but not racist. But like, still has a lot of really bad stuff. And also it doesn't have niche communities like Twitter does. It's just... It's Twitter blue check marks, but less racist. Did I say more racist before? I meant less racist. It would be hard to be more racist than Twitter. But yeah, it's Twitter blue checkmark, slightly less racist, because let's face it. So no, absolutely not. Manager level and higher. Oh, I think I told the story of the LinkedIn influencer that I sat next to on a plane once. That was a very fun experience, watching him shit post on LinkedIn at 7 a.m. Oh, wow. That was a whole thing. Alright. Well, thank you so much for joining, everybody. So my next stream is going to be same time as today, 3 p.m. Central European Time, 2 p.m. UK Time, 1 p.m. Middle of the Ocean Time, 12 p.m. more Middle of the Ocean Time. I'm done with that bullshit. 3 p.m. Central European Time, 2 p.m. UK Time. And we're going to continue working on the file system, which is actually going quite well. I'll see you then.